recovery boilers, lot many process waste is there. That heat can be utilized for the energy productions. That will be also reducing the burden on the fossil fuels. Next is the waste to energy. There are the municipal waste, there can be industrial waste. Those waste can be utilized for the energy generation. So that is another area. Finally, alternative fuels. Some of the alternative fuels like a hydrogen. Hydrogen can be one of the future fuel. Why? Because the hydrogen will be clean fuel. It will not be producing any carbon dioxide. Or not only hydrogen, there can be many more fuels which is richer in the hydrogen will be serving as an alternative fuels. Carbon capture, utilization and storage is one of the area. Lot many work is happening. In the future, we'll see that the carbon emission of the boiler will be decreasing significantly because of the carbon capture and utilizations. And last is the digitalization. Digitalization can also play a significant role when you are talking about that how the energy generation, energy utilization will be doing, how the efficient energy generation, energy utilization, there the digitalization has to play a big role. So these are some of the technology area where that changes are taking place in the technological space. So first part is the energy efficiency, the most simple things. So the simplest thing is that why are we recovering the flue gas? Whatever the heat we are having in the flue gas, at what temperature we are throwing it, whether we are recovering. But mostly that will be having the HRU, but sometimes some constraint is also coming. Many times you will not have the sufficient heat sink. What is the heat sink? That whenever that some heat is available, source is available, we will have to transfer that heat to somewhere else, so that wherever that we are transferring, like in our case, it is a combustion air, so combustion air preheating, feed water preheating, makeup water heating. So these are some of that sinks are available. So one is that constraint or challenges there is that there should be the right sink will be available for that energy utilizations. Next is that because you are operating at a lower temperature, heat transfer performance will be poor because that log mean temperature difference or temperature difference is less. So obviously it will be requiring more area for that heat transfer there. So this is one of the challenge. And last, which is very, very important, is the low end corrosion. Many times we are burning furnace oil type of fuels, which is rich in the sulfur. Normally in the furnace oil, we are having 3.5 to 4.5% sulfur. And after the oxidation of the sulfur, it will be generating sulfur dioxide and sulfur trioxide, which can react with the water vapor, and it can make sulfurous and sulfuric acid. The condensation of the sulfuric and sulfurous acid can take place, and it can cause the corrosion of the tubes or heat transfer surface or chimney. That is called low-end corrosion. So this is one of the area which is quite challenge, in fact, that when you are talking about flue gas heat recovery. Some of the solution is that you can increase, you can preheat that feed water. Assume that I am preheating the feed water beyond my dew point temperature, then the condensation of the flue gas can be eliminated and the corrosion can be reduced. In fact, or corrosion can be eliminated. So we can preheat this one. That can be one of the way. Another interesting way, which is very, very important things, there's a secondary medium. You can utilize secondary medium. What it means? Normally, if you see for the heat recovery station, assume that I go for the combustion air preheater or I go for that feed water heater. What is happening that we take the flue gas and flue gas heat is directly getting transferred to the feed water. Then that what happens in this case, metal temperature will be nearer to the feed water temperature. And if the metal temperature will be nearer to the feed water temperature, it is less than the dew point and the condensation of the flue gas will be taking place, causing the corrosion. But if we can utilize a secondary medium, means that we will be dividing the heat recovery in two parts. Some mediums will be taking the heat from the flue gas and it can transfer the heat to that might be combustion air or the feed water. So might be that we can have the flue gas cooler or feed water heater or might be combustion air heater. So two heat exchangers we can have, and in between that secondary medium we can circulate. Then that it is possible that we can increase the temperature beyond that condensation limit, beyond the dew point temperature, and condensation can be completely avoided. Another can be the thermo-siphon loop. Normally many of you would have heard of the heat pipe. In the heat pipe what happens? In heat pipe that you are using certain fuel when you go to the flue gas cooler sections, it receives the heat from the flue gas, and where the air is getting heated, then it transfers the heat to the combustion air. In that way also, that metal temperature can be maintained by selecting the right fluid, or by selecting the right vacuum levels. Metal temperature can be maintained beyond the dew point temperature, and condensation can be avoided. So these are some of the methods that flue gas heat recovery without any dew point condensation you can have. I'm talking then another thing here about the low temperature heat recovery. Even that whatever the heat recovery we are having, at what temperature we are throwing the flue gas. Might be at the 160 degree, sometime at the 140 degree centigrade also, but still that it has some good amount of the heat available. So what we should be doing with that heat? So for that, there is a technology called condensing heat exchanger. What is condensing heat exchanger? It is just an opposite concept that earlier I was talking about. We should be avoiding that condensation of the flue gas. And now I am talking about how we can maximize the condensation of the flue gas. If I select the right material, which will be suitable for the corrosion, then that I can increase the condensation. So I can maintain my temperature that below the dew point temperature of water vapor, and condensation can be increased, and then that even not only sensible heat, but even the latent heat can be recovered. In that way, it is possible in the case of natural gas. Why I'm talking the example of natural gas. Natural gas is more rich in the hydrogen, so water vapor is much higher in the case of natural gas. It is possible that efficiency of the boiler can be increased beyond 105%. You can go 103, 104, 105% efficiency. Based on that, how much heat sink is available? Definitely the question would have come that how that efficiency can go beyond 100%. Reason is that if when you are going for the heat recovery, and if that you can utilize something, because we are defining the efficiency on the basis of net calorific value, and when you are defining the efficiency on the basis of net calorific value, some of the heat we have already considered as a lost. And by using this latent recovery, that you have already taken that heat back, so efficiency can beat 100%. You can go beyond 100% also. So this is one of the interesting technology can be utilized. Another things can be the heat pump for the low temperature heat recovery. Heat pump can be utilized. In case of the heat pump, why heat pump is so useful? Because you can recover the heat at a very low temperature, but your utilization requirement will be at the higher temperature. So you can pump that by using that vapor compression heat pumps. So you can see here, there are the sections. Here that we have that evaporator sections. At that sections, you will recover the heat, and then there is a compressor, and then there is a condenser. In the condenser section, heat can be rejected at the higher temperature and can be utilized in the process. So that is another way that we can recover and we can increase the system efficiency. Another thing, very interesting thing is happening. We always talk about the generation part. We are not giving that much focus on the utilization part. Many times, just now examples, I told that even sometime our boiler efficiency can go beyond 100%. But that when you are talking boiler efficiency, it is fine. But if you go for the complete system efficiency, it will be still between 60 to 70%. Reason is that how the heat is getting utilized, whether that whatever that steam is coming, flash steam we are utilizing or not, condensate how much we are utilizing. So it will depend, complete system efficiency will be dependent on this condensate and flash steam recovery as well. So there are many technologies there. We can focus on the system efficiency. There is something called run-around system. Many times it can happen. Some of the heat source is available in the boiler, flue gas, but that we don't have the sufficient heat sink. But we can utilize at somewhere at the processes. So we can go for the run-around system where heat will be recovered at this place and can be transferred to the user by pumping the heat to some other places. So there is some system called run-around system. Another area can be that you can have the integration of the boiler and heater. Many times you have the boiler requirement, heater requirement both. Heater doesn't have the sufficient heat sink. Boiler can have sufficient heat sink. So that integration is going to help. In fact, it can maximize the efficiency. Another area is the process integration or pinch technology. You can see there that in all plants you have that heat utility, heating utility, cooling utility. It is possible that by integration, pinch technology and process integration or energy integration, you can minimize the both heating utility and cooling utility, and you can maximize the efficiency. Another area we have talked about biomass as an alternative fuels. So there are certain challenges with respect to the biomass. And what are the challenge for the biomass? Normally when you're talking biomass, biomass is having the low bulk density. Most of the biomass has the low bulk density. Just for example, coal is having bulk density more than 800 kg per cubic meter. But what is the bulk density for rice husk? It is only 120 kg per cubic meter. If I go for the rice straw, in the baled form, it is 70 kg per cubic meter. If you go for non-baled form, it becomes 30 to 40 kg per cubic meter. So normally biomass has a low bulk density, and it is very challenging how to deal with the low bulk density. Biomass also will have the low calorific value. It also have the higher moisture. So these are some of the challenges of the biomass. Other than that, most of the biomass will be rich in the alkali. Alkali means sodium and potassium salt will be higher in the biomass. It is required for the growth of the plant, so it is present there. But mostly that biomass will be rich in that. And this sodium and potassium salt will be having ash softening temperature will be quite less. And because the ash softening temperature is quite less, it can, if my flue gas temperature goes high, it can cause that clinker formation. If the bed temperature goes high, clinker formation. If that my furnace temperature go high, it can cause slagging. And if my furnace exit temperature goes high, it can cause falling of the convection pass. And that will be reducing that, it will be increasing the dawn time. So this is one of the challenging area. But the biggest challenge is something else, that is inconsistent supply of the fuel and the seasonal variation of the biomass. Normally that one biomass will not be always or continuously available. Biomass keeps on changing. Some biomass is available for a particular season. It will not be available in the other season. So whenever the biomass boiler should be designed, it should be designed for the fuel flexibility. If the fuel flexibility is not there, biomass boiler utilization will be always a problem. Some of the technology which is being utilized for the biomass combustion, fluidized bed combustion, but the application is restricted. Only few fuels can be utilized in the fluidized bed combustion. Traveling grate can be another technology. And most recent, mostly we are talking about reciprocating grate technology. And there is a reason that why reciprocating grate technology is getting utilized. Normally what happens, in fact, assume that you think about a traveling grate. Fuel enters at one place, and there is no relative motion between the fuel and the grate. Fuel remains in the same position. So normally if the fuel bulk density is very less, or if moisture level is very high, calorific value is less, then you will be requiring more voluminous fuel will be there, layer thickness will be very high, top section can participate in the combustion, bottom section will not participate in the combustion so effectively. So how this problem can be solved? By using the reciprocating grate technology, where that grate is not moving, at the place of that, grate is pushing the fuel to the different combustion zone. When I'm talking different combustion zone, biomass goes to the different phases of combustion. It goes for the moisture removal, it goes for the volatile generations, it goes for volatile combustion, char combustion, and ash removal. So it goes to the various phases of the combustion. So what is happening? Grate is pushing the fuel to the different zone so that tumbling of the fuel will be taking place, intermixing of the fuel will be taking place, which increases the efficiency of the combustion. Normally that lot of the development has taken place in the grate. Grates are divided in the multiple trolley systems. Means one grate will not have the single motion or same speed. Why? Because whatever the various stages I have talked about, all stages require a different speed. Like a volatile generation and combustion is a very fast process, but char combustion is a very slow process. So all processes, some fuel can have more moisture, requires more drying time, some fuels will be drier, require less drying times. So that was the reason that it keeps on changing. It is as a function of the fuel, it will keep on changing. So that grate is divided in the multiple trolley. Each trolley will be moving with a different speed. Based on that, whatever the fuel and fuel characteristic is there, that you can adjust the speed, and accordingly that fuel flexibility of the boiler can be achieved in fact. Not only that, even the air requirement for the different processes or different stages are different, so that all trolleys, everything will be connected to the different air connection. So you can control the air in the different sections. And by this, that we can meet a major requirement of the fuel flexibility, because fuel can move with a combination of the different speed. Fuel can go with the different type of air distributions which will be required for the biomass combustion. So multiple trolley with independent air control, multiple lookup table for the different fuel and fuel combination. Many times you have the 6 fuels, 7 fuels. You can have a separate lookup table. What is lookup table? Lookup table is basically a boiler control table, where as a function of the load you write how much should be the air, which damper should be open, what should the fuel quantity. All of these things you are controlling the boiler. So lookup table can change as a function of the function of the fuel. So you can have multiple lookup table. So based on that, whatever the fuel you are selecting, you can select a particular lookup table, and you can have the optimum combustion for that fuel. Oxygen trimming. Other than that, even that if particular trolley that if you want to have the effective utilization, then you can have the multiple casting design. Same casting designs is not going to help you, because same casting means you can only control the air in a particular trolley. But within the trolley, if you want to control the air, then you'll have to go for the different design of the casting, where some casting can allow more air to come, some casting can allow less air to come. So you can maximize the efficiency of the trolley itself. Utilization of trolley can be maximized by the multiple casting design. Some of the things has to be done in that, as I told you initially, the falling is a very, very important characteristics. And because that most of the biomass is having the falling characteristics, that was the reason it is very important to understand how that we can overcome that. And we can overcome by having a right pressure part design. We can have to give that right area there, because if you are reducing the area, then what will be happening? My temperature, bed temperature can go high. My furnace temperature can go high, which can lead to the slagging. If my furnace exit temperature go high, it can lead to that falling. So to resolve this problem, we'll have to see that how we can have optimum temperature zone. Why I'm using the word optimum? If I'm using very less temperature, then also it is dangerous. Why? Because if you'll be operating the boiler at a very low temperature, then the effective utilization of the volatile will not be taking place. You'll be escaping a lot of the volatile. So for the effective utilization of the volatile, you require to have an optimum temperature, not very less, not very high. Very high means more falling, very less means not an effective utilization of the volatile. This is some of the design. You can see that how the flue gas is turning. It is having multiple, membrane panel is divided in the multiple pass. So it will be increasing the residence time for the combustion. At the same time that it will be giving more time for that heat transfer. So whenever the flue gas will be entering to the convective pass, temperature will be sufficiently decreased. So there should not be any problem Other application of the biomass is in thermal oil heater. Design principle remains the same. This is that one of the thermal design. It normally uses MPa and convective pass as a serpentine convective pass. Another interesting application in the biomass we can have, that is multiple utility solutions. Sometimes you are needing the boiler, at the same time that you are needing the heater as well. Assume that I can go for the separate boiler and separate heater. Mostly that is the way we are going, in fact. If we can combine these two, it is possible that whatever the heat integration or energy integration I was talking about, that it is possible that you can maximize the efficiency of the system by doing that sort of heat integration. So multiple utility design also, sometimes it can serve. It is challenging. Why it is challenging? Because it is possible sometimes your load balancing will not be there. Might be that boiler load will be more, heater load requirement will be less. So we'll have to understand that aspects. But if it is possible, then we can also go for multiple utility design. That is going to help, that is going to improve your efficiency. And the best application is energy plant. Normally that it is being used in the MDF industries, where that you have the boiler, heater, and everything has been integrated at one. You can see that there is a flue gas generator, there is a boiler section. Some of the flue gas is taken from there and heat recovery is done. That is the boiler section. At some other places, heat is recovered and this goes to the heater. And there is a mixing chamber, the hot flue gas can go to the process. In energy plant means, in one plant, you are getting both steam, thermal oil, hot thermal oil, and hot gas for the process utilization. This is one of the energy plants picture. Another thing that the alternate source of energy, and this is also very important topic for us. Normally that one of the source can be electricity. Electricity can be one of the alternative source. And why it is so important? Because there are two regions, and both region, one region is currently is very this one. Like if you go for the electricity, you can just think about that. It is a completely clean steam generations you can have. You are not burning any fuel. You are not producing any emission. But then question comes that we are not producing at this place. But might be that we are producing during the electricity generation. And we are generating that, whenever we are generating the electricity, then that per kilowatt basis, you are generating CO2. What is happening this day, a conventional thermal power plants will be generating almost 850 grams of the carbon dioxide per kilowatt of the electricity generation. If you see in India, a lot of the renewable has come. Approximately 37% of that Indian electricity is getting generated by the renewable means. In fact, in many countries, like Denmark is one of the countries which I can think, one of the ideal, in fact, in that way, you can see the 86% of the energy is getting generated from the renewable source only. So if you see that for the 1 kilowatt generation of the electricity, in the Denmark, only 115 or 120 grams of carbon dioxide is getting produced. Currently, whatever the level of renewables we are having, we are producing almost 600 to 700 grams of the carbon dioxide per kilowatt generation of electricity. So slowly when we are moving towards the renewable, it makes a great sense for the CO2 emission perspective also that we should be moving towards the electricity. There are two types of boiler available. There is a low voltage and high voltage. One of the boiler, in fact, that you can see our install, this is low voltage boilers, where that resistance heaters are, resistance heating concept is being used. Normally, some of the benefits is like that, no air pollutions, no hazardous ash, efficiency of almost 99% or 99.5%. Dryness fraction can go as high as the 99%, normally 98%. It can have the very, very high turn-on ratio because you can modularize the heat exchangers. And there is a consistent efficiency at the part load. Normally in the fired boiler, we have a good variation in that efficiency. In electrical boilers, you don't have the variation in the efficiency. Higher uptime because there is no thermal stress here. Why the thermal stress is getting induced in the fired boiler? Because that some portions where the furnace will be there, at some portions tubes will be there, some portions cell is there, all are exposed to the different temperature. And all is connected to the same tube plate, which is causing a lot of thermal stress on the boiler. If you go in the electric boilers, this type of thermal stress is not there because that everywhere only that ST bars are there, nothing else is there. So there is almost zero thermal stress, so very high reliability, ease of maintenance, and mean time between failure is very, very, this one, high. Another very interesting concept, in India it is not very popular today, but in Europe that if you see, it is coming quite popular. Reason is that, just think about that where the renewable level is very high. Just now I have given the example of the Denmark, where that renewable level is 86% energy is coming from the renewable. What happens in the night? Their electricity demand is very less at that time, but generation is very high. When the generation is high, but demand is less, what will do? Might be that you can reduce the generation. But why you should be reducing the generation? Because electricity you are getting free of cost. Then that, what they are doing there, they are promoting that electricity for the utilization of the steam. And this also helps for the grid balancing. Assume that generation is very high and utilization is less, grid will be overloaded, so grid has to be balanced. So at that time, high voltage electrical boilers people have developed there. Without any transformer, it will be connected to the grid and you can utilize the electricity at very high kilovolts, means almost made the boiler for this. So as it is the way it is getting generated without having any transformer, it can be utilized here. But that, how you can utilize here? That earlier I told that we are requiring resistance heater. In this case, you are not requiring resistance heater. At the place of that, water itself is acting like a conductor. And if the water is a conductor and we can pass the electricity through the water itself, heat generation can take place there and the steam generation will be taking place. So this type of boiler will not be requiring any resistance heater. In fact, there are two design is popular. One is the two vessel design. You can see the top vessel, electrodes have been placed. And in that, another is the jet flow design. Earlier that jet flow design came. These days, mostly I think in the Europe that people have shifted towards this one. In the jet flow design, what happens? When the jet is passed, electricity is passed through the jet itself and steam is getting generated. So these are the two designs which is available. Basic application is that, the way I have told, electricity requirement. It acts like a backup boiler many times. Steam production during the lower electricity price, many times you can have the variable electricity tariff. And if it is having that, whenever the electricity cost is less, you can utilize this one. So it is used as a backup boiler. Whenever the electricity cost, electricity price is less, at that time it is getting utilized. Renewable power to the heat and steam, we have already talked about. No thermal stress because there is no pressure part, no heat transfer area. So no thermal stress at all. In fact, I have used the word called intrinsically safe design. What I have used, in fact, normally a conventional boiler with a fired or electrical boilers, what happens? That whenever that any sort of scaling takes place, heat transfer from the water side is reducing and that is increasing the temperature, it can cause the tube punctures, correct? But in the case of this boiler, what is happening? If that any sort of deposition takes place, scaling takes place, your current will be reducing, so heat generation will be reducing. So it will not be increasing the temperature, it will be decreasing the temperature. And that was the reason it is intrinsically safe design. By any case, like a scaling case also, that it is not going to fail. Another area is the waste heat recovery. Waste heat recovery, when I'm talking here, primarily I'm talking about the process heat recovery. All of us know that exhaust gas boilers, mostly from the diesel exhaust or might be that diesel engine exhaust or gas turbine exhaust, you are having very high temperature, 600 to 800 degrees centigrade gas, and it can be utilized in the boilers. Both fire tube design and water tube designs are available. So this is one of the other application can be that it can be also utilized for the absorption chilling, not for the steam generation. So some of the application like process heating, power generation, absorption chilling, it can be. Another thing is that for the process heat recovery many times like a cement industry, a sponge iron, non-ferrous industry, coke oven, people are using that waste heat recovery. A lot of the waste heats are available. So people are using waste heat recovery and they generate the power out of this by using a Rankine cycle. Rankine cycle means conventional steam turbine cycles they are using and generate the power. But what is the more interesting, it is not very popular in India, but it is very, very useful. We can also go for organic Rankine cycle. Organic Rankine cycle especially is more useful when you are going for the lower temperature because Rankine cycle will have the good efficiency only at the higher temperature and pressure. If you are not able to get the higher temperature, Rankine cycle will not be efficient. But if you go for the smaller capacity, if you go for that lower temperature, then the organic Rankine cycle can be a better system. You can see here, there is a heat source, obviously the waste heat, whatever is available. It can transfer heat to the evaporators. It can go to that this one expander, where that organic fluids can expand, or not organic fluid, organic vapor can expand, and then it can generate the powers. Then it comes to the regenerator, where it will be passing some of the heat to that this one. Again in the cycle it will be coming, and then it will go here in the condenser sections. Condensation will be taking place. It will be pumped, and again it will be going regenerator because now it is at lower temperature, so it will be taking the heat from the regenerator, whatever is coming from the turbine. And why it is so important? Because that normally at the turbine outlets, it is not that this one, it is in vapor form itself, so heat recovery is quite easier here. And it is very important because even very low capacity of the expander is available. You can see the van expander for very small capacity, and turbine expander can go even for the greater than 1000 kW, that you can go for turbine expander. So large range of the heat recovery is possible. Many times you can have even thermal oil heater. Thermal oil heater will not be having, might be sufficient heat recovery. There also we can think of that, utilizing that organic Rankine cycle, and we can generate the electricity out of that. Waste to energy is the another area which is quite important. Mostly we are generating a lot of the waste, and whenever that we are generating the waste, we have to understand what to do with the waste in fact. So if we can utilize that waste for the power generation, so we have the municipal waste, industrial waste, some agriculture residue, sewage waste, all of these can be, it will be having a certain calorific value. So this heat can be utilized, and there that you can utilize by the direct combustion, gasification, pyrolysis, anaerobic digestions, pelletization you can do, and that you can generate in the fuel, or you can generate that heat out of that. Might be you can generate the power from here. So these are some of the areas you can utilize. Another things we have talked about alternative fuels. And in alternative fuels that I told that most of the fuels you can see here, I have named the hydrogen, ammonia, and methanol. All are that hydrogen-rich fuels. Why we're talking the hydrogen-rich fuels? Because the ammonia doesn't have any carbon, hydrogen doesn't have any carbon. Methanol has carbon, but only one atom of the carbon in one molecule. In fact, so percentage is quite less. So if you see that how much that carbon dioxide generation will be there, it will be quite less for these fuels. So in the future that people will be shifting towards these fuels. Hydrogen already people have started exploring. Ammonia can be one of the derivation of the hydrogen. Why? Because many times you cannot transport the hydrogen, so people convert the hydrogen in ammonia. Ammonia can be easily transported, and then it can be utilized as a fuel. Hydrogen, what are the benefit of the hydrogen? Obviously, it is a clean combustion because it doesn't produce any sort of acidic elements. It doesn't produce any carbon dioxide, so obviously clean combustion, zero carbon emission, no carbon dioxide at all. It can also have the application in the fuel cell technology. That was the reason that hydrogen will become quite popular. Energy storage and grid balancing, hydrogen, whenever I was just talking about the example of that many times that in the night when the electricity generation is more, you can utilize the electrical boiler. At the place of that, it is also possible that one can do the electrolysis and hydrogen can be stored at that time and for the energy utilization. Energy efficiency and integration and some of the industrial.
Root cause analysis. I think one thing is missing here in this conference. People are talking of, now fracture-based design, where you can live with the defects. So use fracture mechanics, failure analysis diagram. You can predict the failure of the components and things like that, So that thing is missing here. Without knowing the root cause, you cannot solve the problem of boiler industry. So what is your opinion on that?
True. Actually, that root cause analysis will be very, very important. Even the corrosion, when you're talking about, there is so many types of the corrosion. And very small change also that the chemistry is going to play a big role, in fact, in this one. So just it is telling that corrosion is there, and for this corrosion, this is a solution. That is not a right way. That analysis, like that, just now that I was talking about some circulation induced that corrosion that we have seen, where because of circulation, some temperature, there's one, but it was not that normally that fish mouth opening, that whatever we are seeing in the circulation problem. It was a corrosion problem. So this type of problem we are seeing, in fact, we are trying to analyze this. In fact, that we can see a big things might be that I can contact you and we can see that whether we can integrate and we can see that something is possible to be done in this one.
Thanks a lot, sir, for imparting such knowledge with us. And I request Shri B.B. English, sir, Deputy Director, Steam Boilers, Mumbai, please be on the stage to felicitate Mr. Jha, sir. Please be in the center. Thank you so much. Okay. Once again, I welcome all of you on behalf of all the Boiler India team. It's a very grand day for all of us. And now, with such enthusiasm, I want to welcome on stage Dr. Pritesh Shah, sir, for his knowledgeable session on precision emission monitoring, reliability to sustainability. But before that, I want to take the privilege to introduce you with this personality, Dr. Pritesh Shah. Only with clean environment and intentions rises a clean, great nation. Very purposefully said by Dr. Pritesh Shah, chairman of Prima. Pritesh is a dynamic and very optimistic personality born in Jamnagar, Gujarat. With a meager cash amount of rupees 140, Prima equipment was established on October 11, 1992. While designing gas detectors and analyzers for safety, pollution, and environment monitoring products, the priority was the ruggedness and sustainability of equipment. In 1998, got an opportunity to develop continuous stack gas emission monitoring equipment, and that sparked off a new journey in terms of design, development, and innovation. Mr. Pritesh Shah sir has delivered many lectures nationally, internationally. He is running a foundation named Kalabharati Charitable Foundation also. Dr. Pritesh visualize Prima as a proud Indian manufacturer supplying equipment internationally. He would like to serve an increasing number of industries with the most affordable solutions while creating more awareness for environment conservation. His mantra is, if you can visualize it, you can actualize it. So put your hands together and welcome on stage Dr. Pritesh Shah.
Changing part is this. It is, yeah. So this one is it? Yes. Perfect. Thank you. So good afternoon, everyone. I'll be holding back to you for another 30 minutes before you go for your tea. Am I right? That's what you need, basically, because your official time is 3:30 for your tea break. But I'll be holding you for 30 minutes. The reason is, you must keep an attention to this part is, you are going to witness today the things about the emission monitoring. So like boiler technology, boiler working, everything we know, we use boilers. Now the major constraint which has been experienced by India is since 2014, you must be aware about the Central Pollution Control Board has issued certain guidelines for your emission. So the pollutant emission, what you emit in the air, has to be of certain level, certain concentration you cannot cross, and other thing you need to measure continuously about that emission. Now in 2014, I'm putting a little background and then I'll come back to on the presentation what the innovation as the Prima equipment was done in the monitoring equipment. In 2014, these guidelines came about the certain parameters to be measured by the 17 highly polluted industries for their boiler emissions or maybe any combustion emissions for the measuring the pollutants about the SO2, NOx, and particulate matter especially. There was a few words in the guidelines was mentioned that has to be a certain certification of that equipment before you buy. So the certain certification was purely namely as in TUV, and AMCert. This was the lab. Now, there was a lot of confusion between the buyers that what is TUV, is it standard or it's in laboratory. Nowadays, a lot of awareness since 5 years, what we have done, so people have been aware now that TUV is not a standard, it is in laboratory, which carry out the testing of the continuous emission monitoring system or automated monitoring system worldly. In the entire world, they call it as an AMS. So, in 2018, we as a small engineer team of 7 people team at the average age of 28 years, took a challenge to understand what the standards are. Because so-called the TUV, where the all multinational company comes with that we give you a certificate of that continuous emission monitoring system, that it has been certified by the TUV Germany and or the AMCert UK. So the question was reliability. So in spite of these guidelines of 2014, the Indian industry has invested on the basis of that guidelines and about that the standard part that it has to be a certain certified. Almost more than, that's a government figure, is more than $6.5 billion of investment is done by you all people as an industrialist to install an emission monitoring system. And the question is, after 10 years, if you go back and ask the regulators that are the readings can be used for the policy making, they say no. The reason is, we are not sure the readings are true or false, or rather in the simple word what we call as a reliable. They are not sure about that the reading which we are receiving from the certified product which we have proposed in the guidelines are reliable or not. So this was the things which we are with the young team, we are the 7-people team, in industry we call engineers, in government organization they call as a scientist. But the average 29 years of 7 engineers was put on to study the EN standard on which base the TUV laboratory test the product that is called the EN 14181 and EN 15267 standard, widely known as, and then generalized we call as a quality assurance level 1. So we were the first Indian company to have a licensed standard purchased from the EN. We worked on that in 2 years, 2.5 years. We were the laboratory which we mentored to them were ready to get that testing facility accredited by the accreditation board. Unfortunately, Indian accreditation board doesn't have a competency to accredit for that standard. So we have to all the way go to the USA with an international accreditation service. Why I'm telling all this thing? The question is, why we don't create first the testing facility and then the guidelines? You know, we can reach, our scientists can reach to moon, and we can't create a testing laboratory, which in small MSME industry has invested only 8 crore rupees, 8 CR. In fact, the Prime Minister of India has personally intervened into this. And in 2019, maybe a lot of government officers must be sitting here. They can check with that. The Ministry of Environment, Forest and Climate Change has published the first gazette in 2019 and instructed to the CSIR, NPL and CPCB to develop the testing facility as per this EN standard, which I told you, 14181, 15267, that's 3. And allocated around 69 crores or 70, round of 70 crore rupees. You need to check up what is the status in that case. Still, India doesn't have that. But India do have that in that case. So let's move to that journey. Why I'm confidently I can say about this journey is because we are the manufacturer. I'm not a laboratory guy. I'm a manufacturer of continuous emission monitoring system. And being an Indian manufacturer, you face a lot of hurdles while having to compete with a multinational company coming with a certificate, piece of certificate paper from the Europe and from the UK and the Germany. So it is our own duty that let's do it, check it. Is it my equipment is not proper? Let me check. So we went to the EN standard laboratory and sent our equipment for checking, and I'm going to produce here that particular results and the standards here. So, welcome to all. So we'll go with the thought process, how the thought process came, which I already discussed with you. And so deterioration of air quality, industry, environmental quality. The more important what we understand was reliable tested measuring equipment to ensure to have an accurate and credible data. It is not the compliance only. It is not only for compliance कि CPCB में मैंने data भेज दिया, काम खत्म हो गया, और data भी कैसा जाना चाहिए? I'll be English, Hindi will be okay? Yeah. So data भी कैसा जाना चाहिए? जो मेरा ELV लिख के आया है ना consent में कि 100 से ऊपर नहीं जाना है, तो 100 के ऊपर नहीं जाना चाहिए data. We don't think of further that part. So Are the CMS or AMS system accurate, credible? Are they reliable quality and sustainability? Sampling probes are correctly installed? हमारे guidelines में दिया है 8D, 2D सब कुछ दिया है. I hope somebody are aware about the CEMS guidelines into this. But on the periphery or the degree, at what degree I should put my sampling probe, it's something goes under the standard. So calibration function and maintenance part. So my simple questions to everyone is, do you install AMS, CMS for only regulatory compliant purpose? If yes, this seminar is not for you. If no, then probably you can be with me for another 25 minutes. Definitely you will find something, this miracle which has happened in India. By an Indian scientist, very young engineers who has done this part with a very minimum investment, and it is the world's third facility and Asia's only facility is there since last 3 years. And the main important part I'll tell you, it has not reached to you. Why it has not reached to you? Because the regulator feels that हम नहीं कर पाए तो एक छोटी सी प्राइवेट MSME कंपनी कैसे कर देती है. हमारे पास 70 crore. I hope you will think that. So, and who knows this about the facility? Who knows about this facility? I'm in Maharashtra, okay. So Maharashtra Pollution Control Board chairman knows this facility since last 3 years. Central Pollution Control Board chairman and the member secretary knows this facility available in India since last 3 years. The National Green Tribunals Authority, NGT, knows this facility available in India since last 3 years. And still they cry that my data are not reliable because the things has not been implemented. So, because we only work on compliance, I wish that you utilize for process optimization, environment conservation, and really want to save money. Do you want these 3 things? Then another 22 minutes is for you. So we'll be talking about quality assurance level 1, where the international standards are applied, where this your Indian guidelines is. Why I've always talked about the EN standard? Because I've been forced by the guidelines published in 2014 by the regulators that you have to work on this. So I'm working on that because there is no BIS standard or IS standard, and neither there is any working is done in the last 10, 12 years to have an Indian standard, testing standard for the emission monitoring system for my Indian industry who has invested more than $6.5 billion and for the conservation of environment and for the future of their children in that case. So what is the definition of quality assurance? We want a systematic approach, not haphazard. कोई भी थैला लेके इक्विपमेंट बना के लेके आया, कहीं से भी उठा के लेके आया, डाल दिया, सैंपलिंग किया, रीडिंग आ गया, मैंने भेज दिया. No. Here is a systematic approach where you can have to achieve the quality assurance. Second is set of quality control measures. So you have a measures, you can control. There are the definitions कि इस तरह से ये data होना चाहिए. And systematic assessment and verification, the most important. And that is the reason the standard called EN 14181 and 15267-3 comes with a quality assurance level 1. Now what is this? Can I have a back? Yeah. So now there are type of call. See, most important, now you can evaluate. I'm not going to speak. I'm going to say. This is everything available on Google. Only thing I have experience, so I have derived. But you can cross-check, you can take the photograph of the screen, you can cross-check on the Google. Now, most important, suppose I say I have a continuous emission, or you have a continuous emission monitoring system, which has been TUV certified or an AMSAT certified, which you purchased in 2014. So now that is called a coil 1, quality assurance learn, because before installation of CEMS, frequency once only, which you purchase because you have a certificate of that, Who has done that? By accredited laboratory. So manufacturers send that equipment to that accredited laboratory, जो हिंदुस्तान में सिर्फ 3 साल पहले आया, उसके पहले तो था ही नहीं, दो ही जगह पे था. That was in TU Ireland, Germany, and is an NPL UK testing facility. Then relevant standards and relevant clauses. Now Coil 2, what it says, post installation with calibration at least every 5 years. Who can do this? Accredited lab. That means the people, those who have industry, those who have purchased the equipment, CEMS in 2014 or later, every 5 years, they remove the system from the chimney and they ship to the Germany or either UK to continue the certification of that equipment. Am I right? This is the standard says. I don't say. Furthermore, Coil 3, okay, that is a regularly the user has to do as per the manufacturer's operational manual. The fourth part is AST, annual surveillance test. After 1 year of Coil 1, that means in 2014, when you have a certified product, after every year, you have to go with AST. Who can do that AST? Accredited laboratory. That means हर साल अपना equipment जो भी आपने लगाया है XYZ कंपनी का, वो आप चिमनी से निकालते होंगे, वापस शिप करते होंगे, वापस वो आता होगा. Am I right? No. So the problem is, guidelines, we blindly follow the guidelines. We never ask a question to regulator, what is the next? If I'm investing in maybe a $4 billion or $4 million or 4 million rupees, what is I'm going to credible results or reliability I'm going to get after this installation? So this is what my equipment was sent to this laboratory. We are performing this since last 2.5 years now. So this is what the level of the Coil 1 is a quality assurance level 1. The Coil 1 के नीचे क्या आता है? EN 15267 2 and 3. 3 is basically a test part. 1 and 2 is a primary. The primary part is, suppose I have a collaboration, means I have a made in India. Narendra Modi sir ने बोला कि made in India, make in India करो. So a lot of multinational companies, what they did, they purchased and shared here and they made the company name as India Limited. Okay? And they started selling the equipment with the certificate of Europe. And they says that we are making here, but certificate of Europe, you can't. The origin manufacture, origin place of equipment, this 152671 and 2 says, the original manufacturing place has to undergo with the standard regulations. I cannot have a buy equipment from Japan or maybe China or from Italy. Okay, I can say made in India and I can say the certificate of German laboratory, okay, this is certified, my model, and it is manufactured in made in China or maybe Vietnam or maybe in somewhere else in India. This is purely and wrong practice. But however, we don't know that part. Second thing, the equipment has to go with the conformity of European standard certified CE laws of 61010. It has to pass, it has to be tested in the laboratory, and then only further that third part comes into the picture. And third part, we have a two-part. One is a laboratory test and another field test. We'll discuss on that. So these are the tests. These are the number of tests in the laboratory. Let me give a caution here. There is one Indian company, TUE India. I am saying openly, you know. And people are recording. I think organization is also recording this. He is issuing now certificate of that certain CEMS is Coil 1 certified. Doesn't have the accreditation for that. And he checked only for 2 parameters out of this. Be aware when you are buying the equipment. Always ask. मैं एक छोटा सा एग्जांपल दे दूं सर. हम पैथोलॉजी लेबोरेटरी में जाते, ब्लड यूरिन देते, नेक्स्ट डे हमको डॉक्टर सर्टिफिकेट दे देगा तो हम निकल जाएंगे. हम क्या मांगेंगे? हम बोलेंगे भाई हमको रिपोर्ट दे भैया, हमको देखना है मेरा हीमोग्लोबिन ठीक है, HDL ठीक है, LDL ठीक है कि नहीं रेंज में. Tell me one industrialist sitting here who bought a TUE certified product has a test report of the TUE laboratory with them. None of the Indian company, Indian industry has a certificate test report of that laboratory. So the laboratory test, these are the various like zero span, deviation, drift, cross section. They are very important because that's the actually will give you the reliability of your emission monitoring. Unless you have a reliability of the data, you cannot have a policy. Like Dr. Sir abhi bol ke gaya about the sustainability when you have a reliability data. So policy कैसे बनाओगे? आपका data ही reliable नहीं है. Then the field test. Now field test, the most important, I put in one green line, green word, that the determination of homogeneity of EN 15259. What is that? The standard says, I don't say, the standard says, whatever certified product I have, whichever, maybe it's TUV or AMCert, I cannot have an installation done of the sampling probe at the chimney without conducting 15259 test, which is called as an homogeneity test. Homogeneity will be like, you may be knowing about the isokinetic sampling. Isokinetic, the pollution board आता है, वो डंडा डालते हैं, पंप चलता है, सैंपलिंग करता है, थिम्बल में, सॉक्स नॉक्सा लेता है, बबलर में. Okay? Now there is a word called traverse point. You know, there is a cross section of the chimney diameter, and from various points you have to take the sample. That is called an homogeneity. So there is a 3-day test as per 15259. On that data, it has been put into the analytical formula, and the sampling point, not height I am talking, sampling point is been decided where I should put my sampling probe. How many of you have done? 0. Because it costs 75,000 rupees. For 3 days, the laboratory has to be there, analytical laboratory, accredited lab. And we say, no, we install the TV certified product. And we talk about the reliability. Because the regulator knows that it is not reliable. Lekin dhanda hai, to sab kuch karte hai. It's like that. So, and anybody can have question any point of time if I am saying anything out of the syllables. So this is what the field test it is. Now I'll tell you how it happens into that. So this is the primary requirement, as I told you about 152671 and 152672. These are the primary requirement of that. C labeling, security, output range, additional data output, display operational, password protected. This has to be a mandatory part of the CEMS system before it goes to the laboratory for 15267-3 testing. It's clear. Now, these are the tests. I'll move very fast here because there's a lot of... Now, first test, response time. So, these are the tests which actually conducted on the equipment. And I'll tell you, इसमें इतना कुछ भी नहीं है हाई-फाई जो हमारे हिंदुस्तान के बड़े-बड़े साइंटिस्ट नहीं कर सकते. But what is missing, you know? What is missing is an intention. I have clearly seen, I'm in 35 years into the environment field of my career. इतना wastage of money मैंने आज तक नहीं देखा. You know, we are the richest country in the world. I'll tell you wow. Sir, you are a very senior person here, you know. I'll tell you, we are the richest country in the world. 2014 से हम लोग डेटा भेज रहे हैं सेंट्रल पोल्यूशन कंट्रोल बोर्ड में रियल टाइम. हर 2 मिनट में डेटा जा रहा है. बिलियंस ऑफ डाटा जा रहा है. बाद में बोला उसको डेटा सीपीसीपी डायरेक्ट देती नहीं है रेगुलेटर्स. इट हैज टू गो विद द टेक्नोलॉजी प्रोवाइडर डाटा. तो उसका मतलब एक सर्वर मेरा क्लाउड सर्वर टेक्नोलॉजी प्रोवाइडर का हो गया. उसके ऊपर से मैं ट्रांसफर करूंगा रेगुलेटर के सर्वर पे, तो एक स्टोरेज वहां पे हो गया. बाद में 6-7 साल पहले कोई एक कंपनी आया, उन्होंने स्टेट वाले को बताया कि आप स्टेट वाले आप डेटा नहीं लेते क्योंकि वो सीपीसीपी से डायरेक्ट नहीं ले सकते. ऐसा होता है? हो सकता है, डायरेक्ट ले सकते हैं. जैसे लॉगिंग कस्टमर करता है ऐसे स्टेट भी कर सकता है. लेकिन उसको समझाया कि नहीं ये अच्छा प्रोजेक्ट है, तो हर स्टेट वालों ने खुद का एक सर्वर डाला. तो तीसरा डाटा गया स्टेट सर्वर में, और बाद में अब ऑफिसर्स जाते हैं तो बोलते हैं कि आपको भी सेव करना है, इंडस्ट्री को भी डाटा आपको रखना है हर हफ्ते में. Now, unreliable data since last 10 years, these 4 places, अगर सेव कर सकते हैं तो इससे रिचेस्ट कंट्री कौन सा हो सकता है बताइए. Unreliable data. Because I'm not able to hand over to MOEF the data, so you prepare the policy, this is my 10 years of research, my industry has given me the data. Repeatability standard deviation at 0 point and span point. किसी ने सुना भी नहीं होगा. सैम्स ले ले भाई, हमको सॉक्स नॉक्स चाहिए, पीएम चाहिए, सीपीसीबी को डाटा भेजना है, इतना इक्विपमेंट दे दे और कितना सस्ता देगा वो बता दे. और मेंटेनेंस होना नहीं चाहिए, 5 साल ट्रबल फ्री चलना चाहिए, आदमी लगना नहीं चाहिए उसमें. This is happening when you do the enforcement. You don't sit with the industry and say that I am going to provide you a solution, I am going to guide you. अगर आप ये नहीं करेंगे ना, enforcement करेंगे ना, यही रिजल्ट आता है. So lack of it. मेरा एक रेफरेंस मटेरियल जो मैं अप्लाई करता हूं उसका रिजल्ट कितनी बार सही आता है. मैंने 10 बजे दिया, 10:20 को दिया, 10:40 को दिया, 11 बजे दिया. तो एवरी टाइम व्हाट इज चेंजेस आई एम गोइंग टू गेट, बिकॉज दिस इज एन 24/7 monitoring equipment. Drift. Now there are few technologies propagated in India, which is an absolute and the most deteriorate technology, I will say, in the SOx NOx measurement. और CPCB ने guidelines में भी लिखा है वो. He has written that. The drift level, उसलिए CPCB guidelines में क्या लिखा है, अगर आप ये टेक्नोलॉजी यूज करते हो तो आप तो हर हफ्ते में उसको जीरोइंग करना है और हर 15 दिन में उसको स्पान करना है, कैलिब्रेशन करना है. कौन करता है? Influence of ambient temperature. We are different than the world. Our tropical conditions are different. The equipment manufactured in Europe, Germany, it is not the same conditions. मेरे यहाँ temperature -2 डिग्री से 49 डिग्री तक जाता है. इस बार तो 52 डिग्री गया. Is it my equipment which is installed in the chimney at the point is going to give me the same result? If not, doesn't matter. But do I have the test data कि मेरा जो equipment है उसका tolerance level ये आने वाला है when it is at 55 degree temperature? No, because you have been only provided as a certificate, not the test report. Influence of sample gas flow at extractive AMS. Influence of voltage variations, we prone to have into that. Cross sensitivity, because variety of application. अभी waste to energy पे जाएंगे हम लोग, तो there are a lot of other gases are going to come, highly toxic gases going to come into that picture. At that time, what will happen about my SOx NOx reading? Because that's going to affect the HF, HCl, hydrocarbon, there are a lot of things going to come when I'm going to have a waste to energy application into that. So, these are our equipment was sent to the laboratory, and there are the few testing photographs of the laboratory where the test was conducted. Now, field performance test. Now, how that is done? General requirements, the site has to be accordance with the 15259. 15259 कौन सा? Homogeneity वाला. वो किसी ने मेजर ही नहीं किया. कहाँ से वो साइट लाएंगे? So, हमको तो पहले दम निकल गया, पहले तो साइट ढूंढने में. बाद में वो साइट को हमने 15259 किया. And then the laboratory was allowed to do that. And the condition is, you have to have a 3 to 4 months continuously on the same chimney with the 2 identical system has to be tested for entire these parameters. Now, analysis to be performed at the end field test. Close number wise days लिखा हुआ है. How many days our equipment was been kept at the site for testing. So, determination of homogeneity I am specifically mentioned before installation of the sampling probe on the stack. Just for a knowledge, I already told, but this is what is most important thing. And industry as an industry also, I request you all, when you deal with that supplier, okay, either manufacturer, when you are on the buying mode, allow them to charge for that. Allow them to charge for that. Otherwise, it's no use. Functional test, calibration function. Calibration function, I must say something here. Comprehensive quality assurance, real world calibration. There is a difference between gas cylinder calibration. तो calibration कैसे होता है? I'll tell you a small example. Yeah, I have it 10 minutes more. I'll tell you a small example. Gas detector. You have a lot of people even have a safety gas detector installed. Now, the audit comes, no, accreditation audit comes, we call in India as an NABL. Audit comes to any laboratory, the auditor will ask the calibration certificate of any measuring device. Am I right? They will ask. तो आप दोगे, तो वो बोलेगा कि नहीं, ये आपने जो calibration करवाया वो NABL lab से है कि नहीं. Am I right? They will ask. Otherwise, they will give you a non-conformity straight away. Just go back to your industry. Check your gas detector calibration certificate, which is for your safety, your family safety, and your plant safety, which has been ignored by accreditation board since last 76 years in India. Challenge. जाके देख लो अपना. गैस डिटेक्टर का क्यों लगाते गैस डिटेक्टर? अपनी सेफ्टी के लिए, बच्चों की सेफ्टी के लिए, प्लांट की सेफ्टी के लिए. उसका एक्रीडेशन लोगो नहीं मांगेगा एनएबीएल ऑडिटर आपके पास. हिंदुस्तान में लैब ही नहीं थी. क्यों नहीं थी वो तो साइंटिस्ट जाने, लेकिन अभी 3 साल से है. चेक. एंड ये मेरी बात नहीं है. ऑल द गवर्नमेंट रिसर्च ऑर्गेनाइजेशन ऑल्सो हैविंग द कैलिब्रेशन सर्टिफिकेट नॉन एक्रीडेटेड, जिसके ऊपर पूरा रिसर्च हो रहा है, जिसकी हेल्प से. So there is a difference I had mentioned. What is the difference for calibration function actually as per EN 14181 and normally with the cylinder, NIST cylinder से जो करते हैं उससे. Response time, lack of fit, systematic deviation, पूरा सबका consider करके क्या deviation आ रहा है, that is the lack of fit. Is it really fit equipment or not? That has to be checked. Maintenance interval, 0 point, deviation from the rated values. So, availability. So, the standard says your equipment should be available for the performance more than 95% at any point of time with that all that state testing parameters. So, I was proud at the day when I got this report from that accredited lab. मेरे को मालूम नहीं था कि 20 साल से मैं जो CEMS बना रहा हूँ वो इतना वर्ल्ड लेवल का है, बिकॉज आई वॉज नॉट टेस्टिंग ऑन द सिस्टमैटिक मेथड. शायद आज भी जो लोग यहां बनाते हैं CEMS, शायद वो टेस्ट कर रहा है तो उनका भी वही इंटरनेशनल लेवल का होगा. दैट मीन्स यू आर इन द रॉ ऑफ एक्सपोर्टिंग, यू आर रेडी टू एक्सपोर्ट दैट इक्विपमेंट, यू आर कैपेबल ऑफ एक्सपोर्टिंग दैट इक्विपमेंट टू द इंटरनेशनल मार्केट. पर हमको मालूम ही नहीं है क्योंकि फैसिलिटी डेवलप ही नहीं हुई इंडिया में टेस्टिंग की. Reproducibility, the most important factors these are. And this is an actual, our equipment was tested by the laboratory at the various sites. You can see there are 2 systems are installed there. There's an isokinetic testing. Is all testing we have a digital record. There is nothing like pen paper se likha hua, kagaj pe. Everything has been data and Modbus or signal and transferred to the digital, all measuring device. Nobody can challenge कि तुमने हाथ से लिख के manipulate किया. Everything is digital. Now, key benefits of this part. Data is reliable and accurate, providing insight into process efficiency. How many officers of Pollutions Board talk about your process efficiency by installing this CEMS system? आपका ESP अगर आप 1.5-2 करोड़ का इंस्टॉल करते हो, लेकिन डस्ट मॉनिटर लगाना है तो वो 40,000 का लगाएंगे. यार दिखाने के लिए 50 दे देगा, रीडिंग बहुत हो गया. लेकिन 2 करोड़ का ESP का एफिशिएंसी कौन बताएगा? वो जाने दो, कैपेक्स हो गया. Operational cost, the electrical consumption you do to operate that ESP, calculate करो OPEX. अगर मैं अच्छा सा गैस अपना डस्ट मॉनिटर लगाऊं और मेरे को मालूम पड़े कि मेरा थर्ड स्टेज का फ्रीक्वेंसी कम करके मैं इलेक्ट्रिसिटी 50 यूनिट बचा सकता हूं, वो पेबैक हो गया आपका. दैट इज कॉल्ड प्रोसेस ऑप्टिमाइजेशन, कॉस्ट सेविंग, मनी सेविंग while using the pollution monitoring equipment and all that. So, efficiency of the process, reducing the production cost and minimizing the waste, and test report compliance certification. You are sure, you are double sure that my products are working and providing the truthful results. So this is the product which we are given for testing. And this is, we proudly, we are in a booth here also. And since last 2.5 years, in national, international conferences, conventions, and expos, we display in 6x4 feet there the world's only continuous emission monitoring system, which comes with EN 14181, EN 15267-3 test report. मेरे को सर्टिफिकेट से कोई लेना देना नहीं है. टेस्ट रिपोर्ट क्यों चाहिए? 6 महीने के बाद मैं जब कैलिब्रेशन करूंगा सर, तो एटलीस्ट मेरे को मालूम पड़े पहले का डिविएशन क्या था, पहले का टॉलरेंस क्या था, पहले का अनसर्टनिटी क्या था इक्विपमेंट का. तभी तो मैं अभी रिपोर्ट कर पाऊंगा ना कि इट इज सही है, बिगड़ा है, नहीं बिगड़ा है, रिपेयर करना है, नहीं करना है उसमें. लेकिन वो मेरे को मालूम ही नहीं है. बट वी डू प्रोवाइड 135 पेज test report, and this is the world's only company who comes and provides you authentic accredited lab test report with every CEMS into that. So, where are the facilities? These are the 3 facilities now. One is in UK, as I told you, in National Physical Laboratory, London. Second is TU Ireland, Germany. And third is TCQA Labs Private Limited in India since 2022, 21 probably, and 22. They have been the Asia's only testing laboratory where you can send your CEMS system, or if you already have installed system, probably you can call for an annual surveillance test or maybe QL2 or like that. You can that. But this is, however, subject to. The thing is, still the regulators are not able to digest the things because it has not come from the government portfolios, bureaucratic portfolios, you know. So let's hope. We are innovators, we are engineers, we do always good for proud for our nation. And if I am able to save few $1 billion of my country, probably it's good part for me as an industrialist, as an innovator. I feel that we have done something good for our nation. And this 25 minutes or 30 minutes, I'm sure has been enriched in your look towards the emission monitoring system. उसको कैसा होना चाहिए, क्या होना चाहिए. और कल से, यानी आज से आप जब भी अपना emission monitoring system use करते हो, डाटा देखते हो, क्वेश्चन जरूर करोगे, are these reliable? If not reliable, then probably I will not kiss my child and my wife in the evening, and I will not be hypocritic and saying her or to my bachas that I am creating a better future for you. Am I right? We don't have a right to do that unless we know that I am reliable. You know that case. So, world's only CEMS delivered compliance QL1 with test report. For each clause, the underlined word is for each clause of, yeah, done. So, ensuring reliability to sustainability. Until you have reliability, you can't have it. अभी मोदी साहब ने बोला ESG तो सबने ESG डिपार्टमेंट खोल दिया कंपनी में, सब लोग मेजरमेंट शुरू करना हो गया, सस्टेनेबिलिटी बनाने लगे. Sustainability comes, the most ingredient of the sustainability is reliable data. If you don't have reliable data, your sustainability is not going to work. The policies any made will going to get destroyed. or going to get fail. Maybe you will not find, because I am here for another 25 years, or maybe you another for 10 years, but your children is going to face after 20 years. जो पॉलिसी बनाया था ने वो गलत डाटा पे था, इसलिए आज वो फेल हो गया. लेकिन हम तो होने वाले नहीं है, तो टेंशन भी नहीं है. But at least we should not leave the world like that. Let be true to what we do, and anytime if you have any questions, please feel free. Thank you so much.
Dr. Shah, a very quick question, Dr. Shah.
Yes, sir.
I think the products that you are analyzing is sulfur dioxide, NOx, dust, isn't it?
Yes.
All the ingredients of air.
Yeah, I mean, it's not a source emission. Source emission.
Right.
Yeah.
So now, every chimney is emitting these things at certain heights.
Yes.
So is it important, because it gets distributed in the air, so it affects the air quality.
That's true.
And nowadays, we find every nook and corner, there is a air monitoring thing, where it gives you this particular material, this thing, that thing, So which is valid? Because now the product responsibility is there. If you are making some product, like even chocolate, the wrapper has to be sustainable.
I understood, sir. I need a permission from ma'am for 2 minutes to reply for that. Yeah, because ये थोड़ा धड़कता भड़कता जवाब है. हाँ, थोड़ा आप लोगों को शर्म आएगी अपने आप पे. ऐसा है. Source ambient air quality बिगड़ता कहाँ से है? Source emission से. That is what the regulator says. So source emission से हवा नीचे आई तो हवा में गई और हमारे सांसों में गई. So there is a standard. National Ambient Air Quality Standard है. Central Pollution Board का Air Act के अंदर है ये. It is a legal. Okay? वो gazette publish हुआ है. उसमें लिखा हुआ है कि you have to measure with certain technology. You have to use certain measurement technology for the ambient air quality monitoring system. The technology is costly. अभी 5 साल पहले हमने पहला बनाना शुरू किया इंडिया में, बाकी सब इंपोर्ट होता है. वो करीबन पहले तो 1.5-2 करोड़ में बिका हुआ है वो. आज जो इंडिया में बनना शुरू हुआ तो 60-70 लाख पे आ गया वो. ठीक है. Now that is reliable, you say. But Dr. C. Sharma of National Physical Laboratory, he was a part of that research project. उसने एक आर्टिकल लिखा था, 99% of the CEMS installed by the government are not validated. आर्टिकल है. ठीक है. सेकेंड पॉइंट, बाद में एक स्मार्ट सिटी आया, अपने प्राइम मिनिस्टर सर का ड्रीम है स्मार्ट सिटी. तो स्मार्ट सिटी में प्रोजेक्ट दिए गए, उसमें अंदर एयर क्वालिटी मॉनिटर लगाने का बोला अलग अलग सिटी के एरिया में. बट देन इट इज नॉट विद द मीटिंग टू द एक्ट. दैट इक्विपमेंट्स आर यूज विद एन सेंसर बेस्ड टेक्नोलॉजी. ऐसा बोल के कर इतना महंगा तो कहां लगाएंगे, तो वो 60-70 हजार रुपया वाला लगा दो पब्लिक को दिखने वाला, बाकी जो गवर्नमेंट का जो लगाना है वो 1.5 करोड़ वाला लगाओ.
Sir, a good advice to you. I am not in a
Yes,
position
yes,
to give
please,
advice.
sir, please, sir.
Say you are good enough to analyze this air. Why don't you go enter into a plant inside, where, all these tubes of the boiler tubes, they are also facing problems. If we'll see into EPRI, Electrical Power Research Institute America, they have, because you are good at sensors.
Yeah.
The sensors are being used everywhere.
Yes, that's
so
true.
you can devise a robotic sensor, which is very miniature, which can go through the pipe and it can monitor, what is happening inside.
No, we have for NDT. I'm good in ultrasonic also. So we have done something for the NDT, not for the corrosion part so far. But anyway, I'll take this point with me and definitely I'll put a team. Thank you so much. If you have any questions, you can meet me. Yeah, please, sir. What?
We are using PNG, pipeline natural gas, as a boiler fuel. So is it applicable for us?
देखो साइंटिफिकली एप्लीकेबल नहीं है, लेकिन आपके रीजनल ऑफिसर पोल्यूशन बोर्ड को, स्टेट पोल्यूशन बोर्ड को पूछ लो, क्योंकि हमारा देश है ने 32 देशों का एक देश बना हुआ है, बराबर है. तो आपने अपने स्टेट पोल्यूशन बोर्ड में क्या उन्होंने खुद का दिमाग लगा के क्या बोला पॉलिसी में, वो आपको उनको ही पूछना पड़ेगा. भगवान माई बाप वो है, साइंटिफिकली नहीं चाहिए.
ओके, थैंक यू.
थैंक यू सो मच. थैंक यू सो मच.
Thank you so much. And I think ये जो सारे topics हैं, these are very vast topics. So please be on the stage for 2 minutes. We want to felicitate you. Yeah, yes. And for this, I want to, yes, call upon stage Shri Anil Zunzure, in charge Joint Director, Solapur Steam Boilers. Sir, please be on the stage to felicitate Dr. Pritesh Shah. तो मैं ये कह रही थी टॉपिक्स बहुत बड़े हैं, इम्पोर्टेंट भी है, उसके बहुत सारे आयाम हैं, तो जो वक्त हमने इन लोगों को दिया है ये काफी नहीं है, ये हम भी जान सकते हैं, आप भी जान रहे हो. Yes, please put your hands together for Mr. Pritesh Shah, sir, Dr. Pritesh Shah, CEO, Prima Equipment. Thank you so much, sir. And let me tell you, sir, all of you, there is a QR code and the banner is near the lift. You can scan the code and get all the technical जो भी पीपीटी प्रेजेंटेशन स्पीकर्स द्वारा यहाँ हो रहे हैं वो टेक्निकल बुक आपको वहां से मिल जाएगी. थैंक यू सर. सो काइंडली प्लीज स्कैन दैट कोड सो दैट आपको किसी पीपीटी की अलग से फोटो लेने की जरूरत है नहीं. तो आपको ये सारा मटेरियल आपके फोन पे मिल जाएगा at your fingertip. So it is near the lift. You can see the banner how to download the ebook. Now here's the time for a short, very short tea break, just for 10 minutes, and after that we will have an international speaker with us. So I hope all of you to be here again in time within only 10 minutes. Just go and have a hot cup of tea, and with this enthusiasm, please be back again. Thank you. Hello. I request all of you to please be seated. In next 5 minutes, we are going to start with our next session. So it's a request for those people who want to attend. Please, जो बाहर खड़े हैं जहां आप शायद और किसी काम में बिजी है, तो लेट योर फ्रेंड्स नो, लेट योर कलीग्स नो कि हम लोग अभी शुरू करें, बिकॉज एज वी डिक्लेयर्ड कि बस 10 मिनट का टी ब्रेक होगा एंड नाउ इट इज़ ओवर. सो वी शुड स्टार्ट इन टाइम बिकॉज ऑलरेडी वी आर रनिंग half an hour late. So it is a humble request to all of you, please be in the stadium, be in the auditorium again. Please make it fast. I think we should wait for more 5 minutes only and then we'll start up. As our speaker, he is already present over here. Mr. Bill Gursky, he is here. And yes, we are very happy to have him, such a knowledgeable person, well-read person, international personality. So it is, what you can say, it is a great opportunity for all of us to hear him. Again, I request, please contact your colleagues, friends. Tell them to be fast, to be present here. Hello, everyone. Good evening. एक चाय की प्याली गरम गरम पी के सब फ्रेश होके आ गए वापस. Very nice to see all of you again. Please, अभी भी अगर कोई बाहर खड़े हैं और वेट कर रहे हैं कि शायद अभी शुरू नहीं होगा, तो let them know कि yes, अभी हम start कर रहे हैं. Because we have the valuable speaker with us, and not to waste his and our valuable time, let us start it. Okay, so let me introduce you, and let me take the privilege to introduce the international speaker of these seminars, Mr. Bill Gursky. He is, for the first time, he is visiting Boiler India, and for the first time, he is visiting India. So, with a huge round of applause, we'll welcome Mr. Bill Gursky on the stage. Yes. Let me introduce him. Actually, उनका परिचय बहुत बड़ा है, but फिर भी I will try. Okay. Mr. Bill Gursky, Director, Sales and Applications, Boiler Burners and Power Solutions, Zico, USA. Director, Global Power, Sales and Applications Engineering. Bill Gursky brings over 33 years of combined industry experience in the utility, industrial, combined cycle, and large commercial markets to his position as Director of Global Power Sales within the Zico Power Group. His industry experience includes executive management, business owner, global business and product development engineering for boiler and burner companies, including combustion engineering. Bill has also authored numerous technical articles and published papers for power engineering. So, please welcome on stage Mr. Bill Gursky for his session today in Boiler India. So.
Thank you very much. It's going to be, I'm used to walking around the stage, so it's going to be difficult to stay in one place. So I'd like to, first of all, I'd like to thank Boiler Expo, the Director of Steam Boilers, for our attendance here, our owner, Darton Zink of Zico, our Managing Director, Sanjeev Chipalkani, my colleagues from Zico, India, and the 250 employees that we have here in Mumbai and also WADA. We thank you for this opportunity to present our information today on conversions for boilers. I'd also like to thank the, sorry, bring it up? Okay, thank you. Now it's working. I'm an engineer, but I can't figure out the microphone. So, I would also like to thank the government of Maharashtra. I'd also like to, again, to thank the Directorate of Steam Boilers for the conversation we had earlier today on safety. Safety of boilers is number one. I have witnessed personally 3 boiler excursions that they call explosions. Having safety for boilers is very, very important. So the fact of the new directorate that they have for the safety here in India, it's a pleasure to be able to be part of this today and to also witness some of the things that are happening in India for the boiler technologies and so forth. So again, thank you very much. So as I mentioned, this is our team that we have here today. Myself, Anand Sutaria, Rajesh Kuwad, Sam Horn, which has joined me from the United States, Devdas Menon from our Middle East office, previously with Thermax, but also Shruti Kulkarni, who is in our expo currently. I'm going to skip through this quickly. So Zico, just a little introduction on the company. Zico is number one in combustion in the world. We do thermal oxidizers, flares, process burners, power burners. We do all different types of combustion for oil and gas and for power. As you can see, we have 26 global offices and 8 manufacturing facilities. We have offices around the world. One of the most important offices that we have is here in India. Our company has been present here for over 20 years. The office was started in 2004. It's a recognition, again, of the importance and the talent that is here in Maharashtra and in this wonderful country of India. The talent of the engineers, the technologists, and the Indian people are part of the reason why we have 250 people here between our engineering staff, our support staff, and our business, and also our fabrication facility. So, again, the talent here is why we're here. Also, as I mentioned, we also have other offices throughout the world to support the same type of business that we have here in India for the rest of the world. We have projects that span 140 different countries, and we're proud to say that. And we bring that technology to the rest of the world. One of the things that is difficult nowadays is engineers and technologists, people who are running their businesses, running their boilers, they need experts to be able to help. We are some of the experts that you can seek out on the combustion side, but we also understand how to boil water, okay, because some of us were on the boiler side of the business for many years. So we understand the relationship between combustion and how the thermal heat transfer goes into a boiler. That's all part of our engineering that we supply. We provide ultra-low NOx and low NOx burners. As I mentioned before, flares and thermal oxidation systems, vapor recovery units. We do rentals of all the equipment that we have, rental flares, vapor recovery units, and so forth. We do a direct replacement of parts. Parts are very important in the industry. If you think about running a boiler, if you think about running your plants, not having spare parts where a valve may take 12 to 16 weeks to acquire from a vendor, and you don't have that valve, so part of your boiler cannot run or the boiler's going to be down, it's very important to have spare parts in your inventory. So something to think about as you're running your boilers. And then we have global field services, and we have that support here in India that supplies our engineering and our field service, supplies support not only for our projects here in India, but also across the world. So we're very proud to have that talent here to support us, especially in the States. So in our test facility in the state of Oklahoma, so if you look at the United States, Oklahoma is just above the state of Texas. It's a small state with a panhandle on it. The location of our test facility is in the eastern northern part of the state. This is a fully integrated test facility. We can test just about any fuel, hydrogen, syngas, pyrolysis, all different types of mixtures for any type of refinery gas. We have the ability to test this in our facility. So if somebody wants to understand the combustion relationship, the combustion products, what's going to happen, the thermal heat transfer within those units, we can do that in our test facility. We have a test boiler. We have a small HRSG that we're building for duct firing and so forth. That's all part of our test facility that we have. This is a picture of our flaring systems that we have. As you can see, the capabilities in that center picture of flaring. You see two young individuals that are there that are pretty close to one of those flares. We have a lot of interns and students that come in as part of our internship. We put them up there next to radiant heat. If they can't handle the radiant heat, they need to find another job. But if they enjoy the heat and the temperature, then we know that they're going to stay with us and they're going to be good engineers to work with us in our company. We also offer, as part of our services, three-dimensional modeling. We do all the 3D of the plants that we work on, boilers, thermal oxidizers, process heaters. We do CFD and physical modeling, and I'm going to talk about that because one of the most important things on the combustion process is equal parts of oxygen meeting equal parts of fuel for proper combustion. You can look at modeling programs, mathematical programs that do predictions every day, okay? It's a mathematical-based system. So if you can't have your prediction program work for what is actually applied in the field, how can you come up with emissions and other things working? So again, that's why we do the CFD and the physical modeling. The majority of the mass flow through a boiler is air, 95% when you're talking about natural gas. 5% is fuel. That 95% is the most critical part. You have to balance that oxygen, that 20.9% oxygen to every molecule of fuel. Then you know that you can get predictable performance, flame, and emissions performance for that boiler. So let's talk a little bit about fuel conversions. As I mentioned, this is our product overview that we do for all the different products and services. Low NOx and ultra low NOx burners we have for packaged boilers, industrial boilers, utility boilers, CFBCs. We do all the piping systems, all the control systems, all related to that. It was mentioned before about the safety of boilers. If you looked at some of the initial pictures that were brought up here, and it was mentioned about boiler explosions, those were small boilers, 50, 20 megawatts at the most, okay? You are now, and permit me, I'm sorry, the conversion of BTUs to megawatts is, I have to work it in my head, but there are utility boilers that are pushing through up to 9 billion, 10 billion BTUs of fuel. Think about from those pictures 100 years ago, 40 years ago, 50 years ago to today. The technology that goes into the boiler designs, the technology that goes into the combustion systems, okay, the technology that goes into the control systems. For utility boilers, there's over 2,000 points that are constantly being monitored from the burner management system and the control system and DCS. Those are all being managed and monitored to make sure that that 9 billion BTUs, or whatever the BTU content in the boiler is safely being controlled by the delivery of the fuel, the delivery of the air, and the combustion process. So, as it was mentioned earlier in some of the presentations, boiler engineers, combustion engineers, okay? When you drive by a plant and you see a stack, think about that. You don't really hear much about that. Why? Because it's safely operating every single day to provide steam for either a process, or it's going from the boiler in a superheat or reheat, and it's going to a steam turbine. Okay, so when you see a combustion engineer or a boiler engineer shake their hand and say, thank you for keeping us safe and providing us reliable power every single day, because these lights, air conditioning systems, and everything else, all that power is being provided by the steam generators, and it's safely operating every day, every minute of every day. Our company has a good amount of experience, 25 years on the average. And just last two slides here, all the different experience that we have from years of experience. And the reason I show some of this is I've been doing this from 33, 34 years. It's kind of tough. And if you looked at the picture as you walked in here of me, I didn't have as much gray. So that was a nice picture. I'm glad that they were able to put that up for me. But that's the experience that we bring to every project, okay? We have, as I mentioned before, we have projects around the world. We've done projects in 140 countries. If you're a boiler owner here, or if you're an operator, okay, that's your specific plant. Do you understand everything that happens in that plant? We need to understand that knowledge when we design a system for you. We can bring a global technical knowledge to your single plant every single day, but you have to share with us the information on how that plant operates to allow us to take our knowledge with your operation and put them together for a safe system. And that's very, very important when you're looking at fuel conversions. We're only going to be at the plant for a visit for 1 or 2 days to gather data. Sharing of that information and allowing us to capture that allows us to understand how you operate, what your operation and maintenance costs are, and so forth. So it's very important to share as much information as you can. And we really stress that when we go on that, because again, the end result is we're going to install the equipment, we're going to provide it for you, but then it's yours. You're going to operate it for years after, 5 years, 10 years. We want to make sure that there's mitigated risk or no risk for the equipment, and that you're going to have a safe and reliable operation for that. And as was mentioned before, those 3 M's that was very important at the beginning, those boiler excursions that I mentioned, okay, it wasn't manpower, it wasn't manufacturing, it was maintenance. The maintenance issues, one was gas, one was oil, and one was coal. One was a pulverizer wasn't operating properly, so it had a very large deposit of slag that dropped into the bottom of the boiler and took tubes out. The other one was a simple oil gun that leaked into the bottom of the furnace. Oil flashed and vaporized. The other one was gas because of a purging problem in the relationship of the fan. Basic maintenance problems that could have been fixed. So that was stressed before. Those 3 N's that were mentioned are absolutely critical to making sure that the boilers are safe and operating. Part of the experience too, last but not least, you can see all the different manufacturers of the boilers that are here. We bring that experience to every project and every different type of boiler here. So that's just part of our knowledge bank. So looking at conversion information, okay, what are some of the primary reasons that you would do a fuel conversion? The main topics and the ones that are underlined are absolutely critical. The emissions, the boiler performance, and the condition assessment. Emissions, one of the things that you want to stress when you're looking at your conversions is best available control technology. What can I do to make sure that not only the boiler is going to be reliable and available, but I'm going to be able to get the lowest emissions out based upon the equipment that I put in? And if there's going to be a change in the regulations or the requirements 5 years, 10 years down the road, can you do what's called future proofing? Can you put a little bit of extra money into the selection that you do for the equipment so that 5 years down the road, you may have to just do a little bit of changes, but not major changes? Those are some of the things that we consider when we look at every single project, from an emissions, from the boiler performance, and then also from the condition assessment of the boiler to make sure that it's going to last and operate for years to come. These conversions can be done on just about any type of boiler, from a utility to an industrial boiler, a packaged boiler, CFBCs, HRSGs. We've been doing these across the world for many years now. So the most important thing that I want to stress is that we have confidence that we can help with just about any type of project. There's not much we can't overcome. There was a discussion about hydrogen before. Around the world, just in the last 6 to 7 years, we have done over 100 boilers with our combustion equipment for hydrogen, up to 100%. The vast majority of those boilers were designed for up to 100% hydrogen firing. Some of those were retrofits. They were originally solid fuel. They went to natural gas, and then we were able to help convert them to hydrogen. And we're looking at right now over 20 utility boilers in other parts of the world for those to not only go to gas, but what's going to happen when you start to fire hydrogen? Can you blend it in 30%? Can you go up to 100%? All of that thermal analysis is what we can do. You marry the thermal analysis to make sure that you can get the steam generation reliably and available, match it with the emissions performance that you need, and you have a comprehensive solution that you can now take and implement into that boiler for safe and reliable steam generation. So that's number one in our mind when we do these projects. Environmental pressures and low emissions. Again, the government of India is looking to do, and I'm not the expert, I know our team here is, and you can seek them out at any time. Other parts of the world I've spent a lot more time on and looking at this, but the emissions performance is something that you're looking at, and then going for a carbon neutral basis. I think it's by 2070. That's important. That may change over time. It may be improved to a better day, maybe 2050. Other locations are doing that. We have the talent. We have our India staff right here. Unbelievable. The amount of engineering talent that is sitting right here to be able to solve these problems is immense, and we can take care of that right here in our office in India. There's a few other things here, and I think the slides are going to be available, and you can take pictures at all, but incentives that the government might provide if you're going to hydrogen. Will that be available at some time? I would like to find that out and know if that's a potential. We're actually working on a technology for hydrogen right now in our test facility in the state of Oklahoma, where we're reforming coal to come up with a hydrogen byproduct. We're going to be introducing that and converting 2 big utility boilers with the design of that system, which should be done in about 6 to 8 weeks. So there's many challenges in eastern parts of India where natural gas is not going to be available because of the length of the pipelines. But you have the ability to get coal in those locations, or you have coal. Well, we have the ability we will have the ability to generate hydrogen by reformation of coal. So we can actually use that now to be able to generate hydrogen locally in the near term. So if there's a plan for that here, we'll be able to support that and work that with you. Where can conversions apply? And if you look here, it's the electric utilities, it's the oil and gas market, the industrial market, steel mills, pulp and paper. Those are all parts of the industry that we can supply the technology solutions in for boilers. So the boiler analysis, so there's a lot of information up here. But the most important thing is you have an asset that if you're a boiler owner or you're a company owner and you have boilers, you've purchased an asset that's been operating for 5 years, 10 years, maybe 50 years, okay? And when you look at some of the older boilers before finite element analysis and some of those systems came in, which are great, most of those had a much more safety factor than they do today because of that finite element analysis. The safety factor sometimes was 4 to 1. And I know there's folks in here that probably were involved in some of those designs. So when you look at some of that, those ability to retrofit some of those older boilers because they're reliable, they just run and run and run. And even the new units today, they're all available for retrofit, okay? But it's really based upon your plant, what you've paid for that asset, you've maintained it, you've spent a lot of money on it. The conversion is possible. The first step, though, is that thermal analysis of the boiler. If I'm going to fire natural gas, if it's going to be a blend with hydrogen, if you're going to take it from coal or oil to either one of those fuels, you want to look at that boiler and make sure that it can accept the fuel. It can transfer the heat in the radiant zones, the convective sections, and making sure that the heat transfer is going to be reliable and proper, because the most important thing is boiling that water. Because if you can't boil the water, you're not going to be able to get it up to pressure. You're not going to be able to deliver it if it's natural circulation or controlled circulation through the boiler to get it to either a process or to get it to a steam turbine to generate power. All of that has to be reviewed. That entire thermal analysis has to be done first to make sure that that gets done. That includes two big important factors when you're thinking. Number one, you have to have the original design data for the boiler. How was the original manufacturer design it? All the data that you have, the drawings, the unit material diagrams, all the different parts of that. That's something that we need to be able to run these thermal analyses. The second part, just as important, and I mentioned this before, you operate the plant. You have these boilers in your system. You have all the data. Your operations staff know them better than anybody. They live with them 24 hours a day, 7 days a week, 365 days a year. We need that information. We need that data. And I know data was talked about by the gentleman before, reliable and accurate data. We have to take that model and build it, and then we have to harmonize it with the existing data to make sure that it operates and the model will operate the way that the boiler operates today. And then we can add in the new fuels and see what has to be changed. I would say 98% of the boilers that we have worked on conversions, done the studies, have not had to have pressure part modifications. Some of it's modifying with excess air, some of it's modifying with a little bit of flue gas, but the vast majority of them have not had to have pressure part changes. And I want to say that again, have not had to have pressure parts. So the cost is in gas burners, depending upon what you're going to do, the valve trains, some improvements, and so forth. And the other thing that's a big benefit, if you're firing a coal-fired unit, there's a lot of parasitic load that goes into pulverizers, gravimetric feeders, if you have precipitators, if you have scrubbers, which are in many locations around the world. All of that is energy that's being taken from the turbine before it's delivered out onto the grid or into the production facility to make profit from the products that that production facility is making. All that power can now be put back into either sale, into the market to provide power like you see here, or into that industrial site to make the product. Those are all the things that we can look at and help with to give a cost-benefit analysis as well as a technical side to be able to help you with the retrofit. These are your plants. We don't know the economics of your facilities. That's your job. But we can give you the information to help you make the right decision. It's your money. We want to help you make the wisest decision with that money, and we're going to be there to help you through that. The rest of this information, again, on the bottom there is, again, the boiler study. And we can, if you want, our booth is C248. If you have questions on this, we'd be happy to talk about this. I only have about 45 minutes or so to go through this. These analyses take, weeks to do that. So it'd be nice to have a specific conversation. This is high-level data, but if you have a specific project that you'd like to talk about, we'll be here tomorrow and we'll be here Friday. We'll be happy to have our staff talk to you, including myself. And we would really enjoy the visit and have that detailed conversation with you. So I talked about the thermal analysis part. Now let's talk about the emissions part. These are all the different factors that you have to consider when you're looking at emissions performance. There's a cost associated with every single one of the emissions performance: burners, overfire air, SNCR, SCR, flue gas recirculation. I had a project with a customer that they were going to shut the plant down, and this was in US dollars, because the emissions regulations required SCRs. The plant manager was a friend of mine. He called me up and said, I know we can do something different. Can you help me? I went to the plant. I talked to him. I got data, spent 3 weeks doing an analysis. I went back to the plant and I presented it to him and his asset manager. We were able to do in-furnace NOx reduction with burners and staging at the cost of $25 million instead of $120 million. So something to think about. Seek out knowledge from those of us who deal with this every day, the vendors. It'd be good to get that, a little bit of a second opinion if you have others who are telling you that you may have to spend additional money. There's always another way to do it. So for most of the projects that we deal with, when we're talking about going to gas or hydrogen, or even if it's a variety of fuels, like in steel mills, you have blast furnace gas and coke oven gas, okay, the modifications to do those. The vast majority of the time, 90% of the time, if not more, we can do it in furnace. And there's ways to do that. And there's a lot of details behind how we can do that. Okay, each boiler is unique unto itself, whether it's an industrial boiler, utility boiler, or CFBC, or a package boiler. Okay, they're all different. You can have 3 units that are identical sitting next to each other, and they all operate differently after 5 years because they're built differently. They're built at different times. Different people are installing it, and the maintenance, reliability, and available are different. You have to treat each one of those unique unto themselves based upon the way that they operate. So that's the part we consider. So for most of the projects, as I mentioned, we try and work on the emissions with an in-furnace solution, which is your lowest cost. And again, we're trying to spend your money wisely on these retrofits to give you the best cost-benefit analysis you can, and future-proof. So when you're looking at the different things that influence NOx, okay, NOx is generated by temperature. Okay, there's an association of nitrogen and oxygen that happens in the furnace. It's all temperature-based. Okay, so if you can reduce the temperature in the boiler, you can reduce that association, which reduces the NOx formation. And we all, NOx formation coming out the stack is a pollutant. It forms ozone. So the areas around the plant can be impacted by that ozone. So there's ways to reduce that by improving the combustion process, okay, to be able to reduce the NOx and improve the region, and in India in general, just to help improve the way of life for everybody here that lives within the country. So these are different impacts. These are different things: combustion air temperature, combustion balance. I mentioned about the association of oxygen and fuel, how it has to meet together so you can predict the way the combustion process happens. That's very important. And if we can do that, and we know where the combustion products and how the combustion is going to happen, we can look at the temperature and be able to drive the NOx down as low as we can while still providing a safe combustion system. But each one of these is very important to how we do that. And again, I can get into details if you'd like to stop by the booth. Just some quick information on this. Again, some of the factors. This just goes back into the NOx and CO. Those are indirectly related. So if you're thinking about your combustion process, typically when your formation of NOx is low, sometimes the relationship of oxygen is not there enough because of mixing, the CO is going to rise. On the inverse, if your CO is very low, it's typically because your excess air levels are high. What happens when you have a high excess air and it's mixing with the fuel? You have more available oxygen, which means typically it's going to be a higher temperature of combustion, therefore you raise the NOx level. But that's where, as I mentioned before, if we can study that and do that modeling, it's important to do that. Then we can mix those in the proper zone in the furnace and be able to give you the best emissions with the safest product. So getting into different things for the candidates, okay, when you're looking at some of the applications. Again, you know your plants better than anybody, but it's the age of the equipment. It's the asset itself. How's the boiler operated over the many years? You know, it's like having best friends. Which one of those boilers is your best friend that you can rely on, that you know is going to be there at 2 o'clock in the morning? It's not going to get, you're not going to get a phone call to come in and fix it. Something's wrong. You may have other ones that are not as good. So you know which ones you would want to convert first versus the others. That could be age-related, it could be maintenance. There's a lot of different factors that go into it. But you know that better than we do, so sharing that information with us is critical. The operation and maintenance cost, okay? Fuel costs for a power plant or even an industrial site, and again, you owners of the plants know this better than anybody, 75 up to 90% of your operations and maintenance cost is fuel. It's tremendous, it's expensive, okay? As I was mentioning about the hydrogen that we're doing across the world and our development project that we have, and I can spend more time with anybody that wants to come and talk to it, but because of the production process that we have, and I can explain it later, the cost of natural gas and the cost of hydrogen is at parity. Okay, so think about that. If we can run this process and produce hydrogen that's the same cost as natural gas, why wouldn't you want to do that in a decarbonized environment? Something to think about. Capacity of the operation. Is the unit running 100% of the time? What is your cost-benefit analysis on it? Is it 50% of the time? Is it worth converting based upon how you operate it? Things you have to consider. Performance. Again, significant upgrades. Have you had to change the boiler? Have you spent a lot of money on it to do upgrades? Upgrading the boiler, the throughput. If you're running a turbine generator, has the rotor been improved over the time with improved blades and what they call swallowing capacity of the turbine? So you upgrade the boiler and you upgrade the turbine to get additional megawatts. If you've invested that money, it's a worthwhile consideration for that boiler and that unit to be upgraded because you've already put money into it, and we can do that. Last but not least, fuel availability. That's again, we talked about that. Where's the plant located? Can you get natural gas? Are you interested in doing a hydrogen product or other fuels? Okay, there's many fuels around the world, but they may not be cost effective for India, like biodiesels, because you have to produce them either locally or you have to ship them from another country. Could be very costly for the shipping. So the cost of that versus other fuels may be high. So it may not be economically feasible based upon the cost of 75 to 90% for the O&M costs on the plants. So just some of the needed information. This is a list of the items. And again, as I mentioned, the most important thing is the sharing of information. These are all the things that we need to learn in the time that we analyze this to be able to help you make the best decision to spend your money wisely on a retrofit basis. Same thing with the fuels. What types of coal do you burn? How does that work within the boiler? Fuel oils. If you're firing oil right now, what type of fuel oils do you have? Do you buy that on a spot market? What's the ultimate analysis? Does it slag the furnace? Is there slagging in the backpass? When does that happen? All that information needs to get shared so we can understand how we need to help you with the conversion. Is it going to be coal-fired with natural gas or another type of fuel? What is the interaction of those two fuels when the boiler's being operated? These are all the things that we can look at to see and make sure that how is that slagging pattern going to change when you're firing a gaseous fuel? Is it going to improve it? Many times it does. I've done a lot of additions of gas on coal-fired units over the last 30 years, and I can tell you that gas helps with coal from a friable ash, especially at full load. It dries it up in certain types of coals, and it helps deslag it, so you get better heat absorption in the radiant section. Doesn't help with fly ash on the backside as much, but these are things that you can learn about your product when you start adding that in. There's a lot of additional benefits that can be recognized. And then existing control systems, ignition systems, and flame scanners, all of those are needed. Can we reuse those? Are those types of equipment that can be reused? And for a coal-fired boiler, when you have a DCS, you're actually going to reduce the inputs and outputs because you're not going to have pulverizers, you're not going to have feeders. There's a lot of different equipment that's no longer going to be needed. So the additive parts that you would have to do for gas trains and some other things from a safety standpoint okay, are not going to be that expensive because the system's already there. It's just changes in the logic and items that you have to put in there. So a lot of times we actually have to help customers find the information. In many parts of the world, engineers in the plants, because operations is so important, a lot of plants, the engineers are in a corporate center. They're no longer at the plants. The operations team spends all of their time operating the plant, not really looking for improvements. So they're spending all that time on that. So they call us and ask us, can you come in and help us with the data? Can you help us come in and look at the engineering and the drawings? Those are all the things that we can help with. And this is just a very short list of the items that we need to look at, some of the conversion parts of the boiler. Last but not least, as far as the conversion, then I'm going to get into a quick case study. Fuel costs, personnel costs, equipment layup, maintenance costs, condition assessment. All of this is part of what we would call an audit. So we can get the technical part for the thermal analysis. We can get the emissions part for how to make sure that we meet the emissions performance for the plant as it's operating. We can also do an audit, almost like a cost-benefit analysis, and almost provide you with a pro forma of how the plant's operating based upon economics. Again, these are your plants. You know your economics better than anything and how you run the plant, how you make your product, how you generate. But we can give you some of that to make your process easier. It really depends upon how much depth you want us to do. These are all the things that we can do for you to help, but it really depends upon what you need. Okay, so enough of the generalities. So now I'm going to get into a CFB conversion. This customer was operating this plant in the state of Texas for about 1.5 years. It was fired, there were 2 boilers fired on petcoke, 1.2 million pounds of steam. They had a variable cost contract for their petcoke. Unfortunately, after 1.5 years, their cost went up by 2 to 3 times because of that variable contract. They couldn't operate the boilers, and they were providing power for their product center, which is about 5 miles down the road. There's about 250 megawatts gross of power that was coming from these generators. Some steam production as well for process. They had to shut the boilers down. We worked with this customer on many process applications, process thermal heaters, and also flaring systems. They called us up and said, we've been working with you on other combustion-related systems. Can you help us? And we said, of course. We understand the combustion process. We understand CFBs. We can work with you on that basis. So we started that analysis, and if you look at that last bullet, it gives some information. So I used to be a CFB engineer from years back, long time ago, 20 years ago, but the basis is still in my brain. Your brain's not a hard drive. You can't pull that information out. So these are things that from the design phase I remembered and said, we can look at this for you from a natural gas firing perspective, and we did. What is a CFB designed for? Solids recirculation. There are CFBCs where you have U-beams and so forth, where the solids go up into the top of the furnace and they drop their way back down an internally recirculating system. These had refractory cyclones, so it's a complete loop seal that goes all the way through to a loop seal or a fluid bed heat exchanger and runs back into the bottom of the boiler. Okay, so it's a complete another component that is required for the efficiency of a circulating fluidized bed. Any other boiler that doesn't have that recirculation of solids doesn't need it. But for these, it's important. Okay? So that was one thing. The heat transfer is different. The radiant to convective balance is different in the CFBC. Okay? How do you boil the water? It's a little bit different in these based upon the heat transfer coefficient and the different surfaces that they have. As I mentioned, the plant was in service for about 1.5 years. Okay? But understanding that it's a boiler, it's a heat exchanger. When you break down a boiler into the basic principles, it's transferring heat through tubing. The tubing is taking that heat and transferring it to water, whether it's natural circulation or controlled circulation, right? The water's boiling. It's looking at the pressure. It's generating pressure. A little bit different on a supercritical, but on a subcritical, it's helping that. So you have to break it down to basic principles. When you look at it, it's just a heat exchanger, and you're going to add another type of fuel into it, it makes it kind of easy. So when we talk to this customer about that, they're like, yeah, you're right, it's boiling water. So we worked our way down and then back up through the thermal models and everything else that we did for this customer to kind of make it easier for them to help them make the decision, especially since they really were only running this plant for a year and a half. They were still in what we would call the infancy, okay, or adolescent phase of operating this plant. They didn't have 10, 15, 20, 30 years, okay? They didn't have that. So they were looking for us for help. You can see the emissions requirements on a pounds per million basis. They didn't want to use flue gas or circulation. They wanted to use in-furnace technology with burners to make the emissions. They wanted to make sure that they had the same steaming rate at the same pressure that they had. Okay? What are we going to do with the cyclone, the ancillary equipment, and then again, the fluidization system? All that had to be modified. So we started off by running the thermal analysis, running different cases, looking at, they had 5 different natural gases that were available. It's in the state of Texas. They had all these they had different methane contents, different ethane contents, okay? Different CO, different nitrogen. All of those had to be analyzed because they were all a different price. So when you're looking at the different contents of the fuels, how did that impact emissions? How did that impact FGR? How did that impact O2? Those all had to get analyzed in addition to the thermal analysis to see what's the best fuel at the best price. And we were able to achieve the emissions with all the different fuels. Some had a little bit of a different safety factor based upon the ethane content, but those were decisions that the plant had to make because the fuel purchase was on them. But we gave them that information to be able to make the right decision. And if fuel prices changed, they know the risk of going to a different fuel and what may have to be changed from that. So we did 6 different thermal analysis in addition to the emissions to run that. And of course, what's the most important thing besides the emissions is making sure that your water wells are protected. Okay, circulation ratios and so forth. All of that had to be reviewed. Circulation analysis. That was all done as part of this project. So, the 2 boxes that are on the bottom below the red, those were the original startup burner locations. So we modified those to add in new horizontal burners. And in the red zone there is where we put the second stage of burners. So when you're looking at a vertical boiler, you not only have the burner that can provide staging of the fuel in the air within the burner itself, but because of the elevation of the furnace, you can use what's called elevation staging. So you can use the whole volume of that boiler to be able to combust the fuel, stage the fuel in a way that it reduces the peak temperatures in the furnace, lowers the NOx emissions, but still gives you that heat transfer that you need to be able to get steam generation and then through the superheater. You can see the fluidizing nozzles at the bottom of the boiler and the refractory, okay? Obviously, in a circulating fluidized bed, in the freeboard area below there, you need that refractory, and there's a water wall behind there, okay? When you're firing gas, you don't need that refractory anymore, okay? There's water wall surface. So our recommendation to the customer is we ask them, please remove the refractory. There's additional heat transfer we can do there, okay? That's going to help with the performance of the boiler to maintain the steaming rate that they had or prior when they were firing the petcoke. They removed that. We removed that. They removed all the studding, okay? Because if you leave studding on tubes and you put heat into it over time, it's going to crack and it's going to propagate into the tubes. So they shaved off all the studs. Took them a little bit of time, but it was worth it. We removed the refractory, and initially they just put a sand bed on top of those nozzles and covered them. Didn't use them anymore. Over time, they removed them and they put a solid base into it. But that was all part of the analysis we did for this customer. Our scope of supply, in addition to the thermal analysis, is the scope you see there from burners to BMS and so forth. One of the things they asked us to do, just in case, if their petcoke got the ability to come back, was they wanted to maintain 80% of that solid fuel firing. So we had some provisions on ash coolers, limestone systems, and so forth that we retained. Even though we covered over the penetrations through the furnace, we kept them. Okay, we kept them all in place. They removed them about a year later once they got it running and they were comfortable with it. But they wanted to keep that, so that was part of our work that we did on this as well. The burner that we use is our free jet burner. Okay, there's a lot of details up here, but the important thing is that this burner is an ultra-low NOx burner. Okay, it fires natural gas, it can fire hydrogen. It was actually born on hydrogen fuels about 25 years ago. There's tens of thousands of this burner out in refinery applications with hydrogen content, 60, 80%. So when we talk about firing hydrogen that we've done in boilers, we've been doing on fired heaters and other units for many, many years, so we understand that relationship. But this burner here, because of the staging effect, it can actually recirculate flue gas and lower the oxygen content near the burner. So instead of 20.9, it's pulling in flue gas, so it actually reduces the O2 18%, 17%. So it stages the gas because the oxygen is not there for combustion. It uses the entire furnace and the elevation of the boiler to be able to reduce that peak temperature to make the emissions that I mentioned before. So a lot of technology went into this, but again, these are the things that we know real well. We actually have one of these on display at our booth. If you'd like to come down and take a look at it, we can explain the details. These are just some of the arrangement drawings that we did for the customer. They just bought the boiler. They didn't want to do this conversion, but they had to. So we did a lot of engineering to give all the details. They did the construction themselves. So we gave them turnkey, as we call it, the lump sum turnkey quality drawings to be able to put these systems in themselves. One of the other things we did, if you look at that middle picture, we built a scaled physical model of the entire combustion air system. Okay, and we had to redesign the combustion air system because on the CFBC or CFB, you may have two different zones. You may have a primary air that's providing high pressure underneath the boiler to keep the bed buoyant. And then you may have secondary air above that to be able to help complete combustion. Okay, those are at two different pressures based upon the location in the boiler. So on this, we actually had to redesign the air heater, which is on the far right-hand side of your picture, and we had to combine it. We had to design a hood system that went over the top of the primary and secondary and unified that. We also had to modify the FD fans and remotor them, so there's a little bit of cost in there because we didn't need the high horsepower fan motors anymore because those 60 inches of water underneath the bed wasn't needed anymore. We only needed about 10 inches through the burners. So we could save all that parasitic load by remotoring the fans, and that paid for itself within a year because of the horsepower savings and the parasitic load and the electrical demand. The physical model that we built there, you can do a CFD if you want to, but we built this and we were able to get this done in weeks, even though it looks like it's pretty enormous, and you can see the size of that with the chair. But we kept that for over a year while we're commissioning it, just in case we had to go back in and make some changes. CFD is great, but we build a physical model for every single one of the projects that we do. It's more cost effective, and we can usually get the performance done there a lot quicker. We have these capabilities in the States and in China, and we have our engineering team here that can do that. The other thing is on that top left-hand side picture, that's the ducting system that we had. So if you look at those top pictures, you can see, I wish the pointer would work on this, but you can see that hood that we designed, and then you have what's called the belt duct. So we were able to design that all around the CFB to get even distribution of the air system to the new burners. So again, that was part of the modeling that we did. We could have done all different types of things with that ducting, but we wanted to be as even as possible, which was the most important thing. So that was all part of our design and installation. So again, physical modeling, as I mentioned before, this is critical. 95% of what goes through any burner is air. And it's getting that balance and making sure that equal parts of oxygen, again, meet equal parts of fuel. And I talked about that already, so I'm going to kind of pass through this slide. The other thing that was important is some of the modifications we had to make on the burner management system. Again, the customer was operating this for 1.5 years. So to help their contractor, because they weren't familiar with putting into BMS as much as they should have, we had to design a system architecture here. So we basically laid out all the panels, all the different control boxes, all the different junction boxes, and had them noted to a parent drawing and all the different drawings in the BMS so they could easily be identified by the contractor, which saved them a lot of time during the construction to be able to install all the different BMS. The BMS was the one thing that had to get added because they were petcoke firing. So that was one of the additions that the customer wanted, and it saved a lot of time. It saved them at least 1.5 weeks of time, which is a lot of money when you have a lot of contractors on site. So last slide. Data, validation, and conclusion. So when we got done with the project, the most important thing is all the burners were within 1% airflow distribution. So we were able to meet equal parts of oxygen and fuel. No problem with meeting the emissions, and we were able to keep CO less than 50 ppm. So it was a really, really good, successful project. The boiler was operating on a steam production, pressure and flow as they wanted to. The only thing we had to do is add a little bit of excess air for convective heat transfer, about 2 to 3%. I know it doesn't sound like much, but it was enough where the superheater was located to provide that benefit. Yes, they sprayed a little bit, but it gave them that cushion to be able to modify excess air and work the sprays to be able to keep that boiler at the right temperature for steam performance going to the turbine. So the entire project, from the time we got a phone call to the time that they started the first unit, was 12 months. The boiler started up on gas in 3 weeks. So think about this. Was a CFB on pet coke. First 4 months of engineering, 8 months of delivery, started it up. 3 weeks it was converted and started up. We shook hands on the customer. They were making power. They gave us the order in 2 weeks for the second unit. Went through that and did that whole project in 8 months, and we started it up in 3 days. So again, knowledge is power. So we were able to do this project with that in that amount of time frame. That was back a number of years ago. They just went back and inspected the burners after a few years. They put scaffolding up. The conditions of the burners are still in excellent shape. Igniters are good, gas tips are good, and so forth, which is bad for us. We would love to sell them spare parts. I'd love to get money from them, but guess what? They don't have to buy any. They do have some, but so bad for us, good for them. But again, that's the engineering that we did for this customer. They had a problem. They were going to shut the boilers down, as the other example that I mentioned before. We were able to help solve a problem for them. And again, that's combustion engineering. So that's the things that we did. So we now have, as I mentioned too, we have about 20 or so CFBs that we're looking at around the world for conversions currently, with a number of other units. So they can be successfully done. So if you have a boiler project that you're looking at, talk to us. Of course, we'd like you to talk to us, but engage vendors. We know a little bit about the combustion side. We know a little bit about the boiler side. And we're going to try and help you make the right decision for what you need to do, especially here in India, where you're trying to meet those decarbonization thoughts. You're trying to look at different fuels, okay? You've got important things to do with your boilers, with your steam. And that's this whole Boiler Expo is all about that, the safe operation of boilers. But it's also the safe conversion of boilers, looking at decarbonization, hydrogen, and so forth, okay? The ability for you to take all this and get into the global market is tremendous. Our team here supports every office that we have. The team that we have here in India supports every office that we have from their engineering talent. It's an incredible office that we have here, and we're very proud to be working with them. And as was mentioned here, it's my first time in India. I am very happy to be here. And again, I want to thank you all for listening. I hope we provided a little bit of information. It was only a few minutes that we had, but this hopefully will give you a little nugget that you can take back and say, let's have a conversation on your conversions and how we can help you. So that's about it. I'd like to spend 2 minutes here and introduce Sanjeev Chipalkatti, our Managing Director in India. He'd like to come up and spend a couple of minutes. Thank you, Sanjeev.
Dear friends, and thank you, Bill, for a very informative presentation there on fuel conversion projects. I'm sure we have learned a lot from this presentation, and I hope many of you will take back some pointers from what Bill has just talked about. On behalf of Zeeco India, I'd like to thank the organizers of Boiler India, particularly the team in Mumbai and Antapurkar Sahab. Thank you so much for the opportunity given to us, and we greatly value our association with the Directorate of Steam Boilers and want to grow this. We have been in Mumbai for the last 20 years. Zeeco started in 1979, but Zeeco India was established in 2004, and we've been supplying equipments to the refinery petrochemical market for the last 20 years. We hope our contributions are now growing and helping the industry to achieve more and more in terms of sustainable combustion projects. Thank you again for allowing us today to give this presentation, and we have a booth here, and we'll be happy to answer any questions and support you on any requirements that you may have. Thank you, sirs.
Thank you very much.
Thanks a lot, sir. Please be on the stage for a few minutes.
Sure, thank you.
Thank you, Mr. Bill, for imparting the knowledge, for sharing these things with us. I hope his valuable words are very, very useful for all of you. And as Sir told, Zico USA, they have their stall in Boiler India Expo. Do visit it and please be comfortable to ask your queries there only, because now we are running a little bit late. So the question and answer session, we cannot have it here only. Okay, now please, can I have Director Mr. Dhaval Antapurkar sir to please be on the stage. We want to felicitate Mr. Bill sir, and I need you to do the honors. Thank you so much, Mr. Bill. Boiler India is a global conclave of boiler and allied industries which provides a unique networking and progress-driven platform that brings together Indian and global boiler and allied industries under one roof. And actually, it's an opportunity for global penetration and expansion. Thank you, sir. Thank you very much. So, guys, there is one session remaining for this first day of Boiler India 2024. I hope all of you will understand, due to inauguration session and all, we are running a little bit late, but still we want all of you, and also you also want the informative session. And for this session, I want to call upon stage Mr. Nagamanikam sir, and before that, I'll take the privilege to introduce him before you. Mr. Nagamanikam sir, retired Executive Director from Bharat Heavy Electricals Limited. Mr. Nagamanikam joined BHEL as an engineer trainee in 1984 at Tiruchirappalli Boiler Plant. With over 37 years of experience, he held various positions of responsibilities within the organization in areas of field engineering services, renovation and modernization, and spares and services business up to general manager. In 2018, he was transferred to BHEL headquarters and took charge as head of SSBG and HERP. He became Executive Director of SSBG and continued till his retirement in 2021. In his journey at SSBG, he directed a steady growth in order booking, project management, execution, and R&M orders. Actually, his job profile itself tells us about his rich experience, varied experience in his workplace, but still I should mention some. He has solved many issues related to boiler and its auxiliaries to the satisfaction of the customers, both in domestic and overseas power plants. Solved many pressure parts, combustion optimization, and tube failure issues for many customers. He has many notable international assignments he has been successfully carried out. Best Engineer Award was conferred on him by IEI in year 2015. He is a life member of Indian Institute of Metals, and many more things actually to share with you, but not to waste his and our valuable time. Yes, I request Mr. Nagamanikam to deliver his valuable session. Sir, are you comfortable over here?
Thank you very much, madam, for the kind introduction. Good evening to all. Respected Director of Boilers, Maharashtra, and the senior officials and all officials of Directorate of Boilers, Maharashtra, and the neighboring states, and all our esteemed learned engineers of power plants. So it is my privilege here to stand in front of you, and the opportunity was given to me by Director of Boilers. So I am thankful to you for this opportunity, because after so long a period, I am trying to just talk about the boiler subject. And because my last 3 years of service was to cater to the whole of power plants with respect to spares and services to our entire nation. So my concentration was not only in boilers, but also in the whole power plant, including turbine generators and electricals, everything. So, but to my heart, I was basically a boiler man. So I started with the boiler plant Tiruchirappalli in the year 1984 as introduced. And then I was a happy person to get involved with various sites across our country and almost all customers and power stations. So I had the opportunity to look at small industrial boilers also, as well as the latest supercritical units which are being installed in our country. And when we look at it, the boilers per se, it is not very much different with respect to the philosophy. Whether it is a small boiler or the large boiler, the steam carrying tubes, headers, the drum or drumless units, which needs a very critical look into the various operation and maintenance point of view. Today, if the availability of the unit is to be there, the boiler is very, very critical. And within boiler has the pressure parts and non-pressure parts. Pressure parts are very critical because even a single failure can put the unit down, and it will be costing us so much, because every day we lose the generation till the unit is brought back. So it is so critical. In this area of maintaining these pressure parts, our boiler directorate and Central Boiler Board plays a vital role, and they have brought in this condition assessment as a requirement, as a mandatory class, so that people are maintaining the units well, and they do regular inspections and the study, so that the boilers are upkept you can say, we are ensuring that the availability, reliability, safety of the boiler is ensured. Because non-pressure parts have got some redundancy. If you take fan or mills or any other part of the boiler, including the electrostatic precipitors and all, we can close down one pass and we can have number of mills, 1 or 2 mills down, and one fan is not there but temporarily. Still the unit can run. But without pressure part, it is important that we adhere to the requirement and the regulation of IBR 391A class with respect to maintainability of the unit and understanding the criticality of the components. And so I will just go through the presentation. You yourself will just see, because I think all of you are experienced and there is no need for me to explain small facts. Kindly go through the presentation. Just go to the next slide, please. Excuse me? Can you just run through the presentation? Any trouble? Yeah, please. Today, you see the installed capacity of our power plants. There are 450,000 megawatt approximately. And out of that, fossil fuel fired plants are nearly 242,000 megawatt units. And with the boilers which are installed right from, you can say, 1960, still the power stations are running. And more than 50% of these units are aged. So it becomes important today, even with respect to the maintaining the optimum level of efficiency, availability, reliability, and also to maintain the greenhouse effect. These units are to be reviewed, and it has to be improved upon so that we meet the requirement of the current the green effect, and then how to go about it. So, and for our large population, the power demand is going to grow over the time only. And of course, fossil fuels are going to be reduced. As per the estimation in 2032 or so, we are supposed to be only 35% the fossil fuel unit should be there, remaining should be renewable energy. So accordingly, but still, the large volume of these units are to be maintained well without any outage. And for new installation, of course, the cost is the factor. And so in this, we can always identify the improvements what can be made into the existing plant and which can be retrofitted, renovated, and modernization can be carried out. Next slide, please. So whatever I have tried to talk about, you can see here, the boilers have to meet the various operating conditions. So today, because of our renewable energy projects which are there, we have to go for base load, cycling, two-shift, sliding pressure operation, trip to house load, and response to FGMO. These things are stressing the components because every time the variation in the load causes pressure temperature variation also. So the components, okay. So boilers again, when the components are subjected to service, they undergo damages like oxidation, corrosion, erosion, creep, and fatigue. So these are all inevitable, and the boiler will go through that. And apart from that, deterioration is also happening due to poor coal quality. That means high ash coals, they erode the second pass tubes, especially economizer and LTSH, low temperature zone, and limitation of equipments, non-availability of quality spares, postponement of overhauls because of the pressure, and lack of good O&M practices sometimes, and aging of equipments. They are putting the units into stress. And if you can look at it, the best maintained power plants, we expect up to 25 years, there is no outage supposed to be there in a large way. But in the reality, it doesn't happen like that. It starts in the year of around 15 years itself because of the stressing of the components, and the units are going into the mode of the forced outages within 15 years. Approximately, if you take the 1 lakh hours of operation, that is what is being given in the IBR 391 regulation as a timeline for conducting these studies. So approximately you can say 12 years to 15 years, these units will get stressed. And after that, when we try to maintain it properly or do some modernization and renovation, then we may go into the 25-year category, and subsequently we can operate even beyond 40 years also. It is all up to us. And worst scenario I am trying to show here. You can see how the plateau supporter structural support failure is being faced in some of the units. And you can see here roof ceiling is totally out, and refractories are collapsed. And you can see water wall bowing and deformation. And these are all due to the explosion kind of operation. And buckstay fouling with the downcomer pipes. And you can see here CRH header and CRH line weld crack due to the support being not there. And you can see how the ceiling header itself has got bent. So this kind of operation is also there. And when it is coming to boiler tubes, it is more so critical. You can see there are something like 21 failure mechanisms, and which is affecting the boiler tubes. Right from the stress rupture category, where the short-term overheating, long-term overheating, that is called creep, high temperature creep, dissimilar metal welds when the stainless steel and alloy steels are welded together. After a certain period of service, they get into trouble. And the water side, when we are looking into it, there are issues like caustic corrosion, hydrogen damage, pitting, stress corrosion cracking, etc. And of course, fire side corrosion is not much there in the coal-fired units, but when it is coming to oil-fired units, yes, it is applicable. And the coal ash, oil ash corrosion and all is taking place. And coming to fatigue, there are 3 different varieties: vibration fatigue, thermal fatigue, and corrosion fatigue. All are present. So we have to be very careful in analyzing these fatigue-related issues. And coming to erosion, fly ash erosion, that is very, very severe in our country because we have got coal with ash percentage over 40%. And because of that, with higher velocity, or even with normal velocity of design, the ash erosion is very high. Falling slag erosion is also there, which affects the bottom arch tubes. And soot blower area erosion, again, because it is not only because of steam, it is again steam plus the ash mix which is going and bombarding the tubes. And coal particle erosion. Then coming the very, very important thing, lack of quality control. That is maintenance related damages and chemical excursion damage, that is doing acid cleaning without proper care, and material defects. When we are replacing the tubes for a repair, we have to be very, very careful about what material we are using and what is the purpose of doing this. We have to understand, and the correct material, correct thickness, and the length with which we are going to replace, it should have adequate margin, and it should not be limited to some small spool area, because very next failure will take place just immediately after that point. So we have to be very careful about the analysis and how much defect is there, that we have to understand. So welding defects, of course, is a very common phenomena. Welding, when we are doing that, much care has to be given on that, and we have to immediately do the required NDT for ensuring that defect-free weld joints are there. So I will show you some of the failures which we can see: the short-term overheating. We can have this long-term overheating or the creep, the bulging type of failures, the dissimilar metal weld failures, the kind of negligence when this is a erosion in the drum. The steam leakage, pure steam leakage alone cannot create such a defect. But with the ash which is embedded over there under that insulation, the ash and then the leakage which is recirculated there and created such a major pitting into the drum. And because of that, the drum has to be repaired, and the boiler was down for almost nearly 3 to 4 months to do the understanding of the gravity of the defect and to create the procedure and to go for the welding. So sagged headers, which is mainly because the ceilings are not properly maintained, and the flame is coming and the high temperature gas is coming and touching the pressure parts, which creates such problems. So then mainstream pipe crack we can see here. We can see how the water walls are deformed. This is the ligament crack. So in the header, inside surface, when we carry out the ultrasonic testing, this was identified, and then with, of course, the boiler directorate, this issue was discussed, and then the operation of the boiler was saved. by doing the study, and then one portion of the header was removed, and then the boiler was allowed to run with sacrificing some of the superheater coils along with that. So when condition assessment is required, when we are coming here, the 1 lakh hours of operation is a statutory requirement, and it is a very much needed condition actually for any boiler. And decreasing trend in availability and PLF, this is an indication. Increasing trend in O&M cost, this is an indication. And of course, when we want to renovate and modernize a plant, then definitely the study is to be carried out. So, of course, we have discussed on this, and again, the study, condition assessment study is going to help us in understanding the left out remaining life of the pressure parts, and which will help us in taking the correct decision on whether to run or repair or to go for replacement decisions. And for R&M, it will be very helpful. Coming to RLA 391, it has got two categories. One for the boiler operating with a superheater outlet temperature of 400 degree and above. Another one is with below 400 degrees centigrade on superheater outlet. So with that, the major thing would be the boilers which are operating above 400 degree, which are more critical, and for which the assessment conditions, what non-destructive testing and destructive testing and analysis, whatever we have to carry out, is all fully, very clearly given in the table number 1 of IBR 391A. So we can see this table. It talks about right from drum to economizer, LTSH, superheater coils, reheater coils, all headers, and piping to the complete, this thing is there. So I will go through that in a very detailed way in the further slides. So when we are trying to do the condition assessment study, how to go about it? This has to be done in 3 phases. One is the review of past operation and maintenance data. And here, the data analysis is very, very crucial. This has to be done by the RLA agency sitting along with the power plant personnels and understand very clearly that how the boiler has been operated, what is the kind of temperature with which it has been operated, and a failure has happened, what is the root cause analysis carried out, and what are all the problems faced, and the length of the services, and in fact, the time period between failures, everything has to be analyzed. Subsequently, based on those data, we have to arrive at the scope of the testing, what is to be done at site physically, that is coming to field testing. So that field testing comprises all the test data, all the test requirements, what has been stipulated in the table. And subsequently, in the third phase, we have to do the very relevant laboratory analysis and the data formulation for the recommendations based on all the 3 phases of study. So here you can say the same thing which has been, what I have discussed up to this point have been put into this table. You can see yourself. So some of the times the power plant will come with the tender. That's why I use the word tender class also. But it is not restricted to a tender class. It has to be very clearly understood. Even if certain tests are not classified or given in the tender class, we have to go through IBR 1953-91A regulation, and we have to do a thorough study based on that. And scheduling of activities have to be planned accordingly, and we have to do the review recommendations and then submission of the proposals for the improvement. So, like, what are the past data? Past data means number of startups, shutdowns, operating conditions, and operating practice, and failures and maintenance when it is coming to maintenance, repair, failures and repair, root cause analysis, details of modification already carried out, repair already carried out, everything has to be taken into account. And coming to field testing, of course, whatever has been classified in the table has been put it here. For every component, visual inspection is very, very important. The experienced engineer who is going to do this work he should be a relevant person having the right experience. This should be done properly so that 70% to 80% of the defects are identified in visual inspection. And based on visual inspection only, further testing is really to be carried out very clearly. So dimensional measurement, of course, for every tubing and then for headers, dimensional measurements are to be carried out. And coming to non-destructive testing, of course, today we have got a wealth of knowledge in non-destructive testing. I need not elaborate so much on that. So right from liquid penetrating inspection, magnetic particle inspection, ultrasonic testing, and coming to fibroscopic inspection for header internal inspection, and in situ axial scale thickness for the high temperature tubes, especially superheater reheater tubes, and metallurgical replication and hardness measurement for all high temperature headers, and in situ hydrogen embedment study for the water wall, if required, mainly because sometimes if the water chemistry is not properly maintained, then hydrogen embedment is a point which we have to take care. And tube sampling and drum deposit analysis have to be taken, and that is to be correlated with other data. And finally, the recommendations have to be arrived based on that. So pressure parts, for the convenience, this has been, I have put the table into like this. We can always classify high temperature, high thickness components in one group, which is very severe. And second thing, low temperature, high thickness components, which are more safer. And high temperature, low thickness components, of course, the coils and superheater tubes, everything will come into this. So this also is very critical. And low temperature, low thickness components, of course, here the temperature may not be an effect, but here the water chemistry and the other aspects like the erosion problems and the explosions, all those things are to be coming into these requirements, and we have to be very, very careful about understanding this. So again, it is classified here. What is the low temperature, high thickness components? Economizer headers, drum, water wall, steam cooled wall headers, downcomers, CRH piping, reheater inlet headers, LTHS inlet headers, all are the low temperature components and high thickness components. We have to see that these components also to be taken into seriousness, and this is to be tested with minimum testing requirements what has been stipulated. So then visual inspection, dimensional, UT, MPI, LPI, replication, all these things are to be carried out. Complete inspection with internal to be done with respect to fibroscope, deposit analysis to be carried out, and of course, when for drum, there is no fibroscopic inspection required because drum we ourselves will go inside and do the visual inspection. And drum suspension is one critical thing which we have to do, whether the load is properly taken by the drum hangers, that is to be identified. We have to see that rocker arm is proper place and all that. Dimension measurement, hardness measurements are additional points which are required here. The low temperature, high thickness components, the components are listed here, you yourself can see. So here, the inside of the headers are to be checked through our the fibroscopic inspection, that is videoscope today, and we can understand all the ligament cracking, corrosion damage, everything. And high temperature, high thickness components, these are all the critical components which may lead into major problems. So we have to be very careful for maximum testing of non-destructive testing, fibroscopic inspection, everything to be carried out for these components, LTHS, outlet headers, D superheater, platen superheater, final superheater, reheater, mainstream piping, HRH piping. These where our focus should be very high. And here, high temperature, the testing what is required have been listed here. Here the main focus should be T-joints in crack-prone areas using NDT checks, and the header stubs, the nipple what we say, the flexibility of those nipples are to be taken into account, and we have to see whether there is any cracking, whether there is any fatigue taking place in that area, thermal expansion, whether it is properly taken into account, and the tubes are behaving properly and there is no failure symptoms. So then coming to piping, so that high temperature, high thickness components के लिए क्या करना है वो पूरा करना है. Apart from that, supporting arrangement is to be studied in detail, and hanger replacement, if required, it has to be suggested. Stress analysis to identify the most stressed points. Piping के लिए, if there are problems, we have to do stress analysis. And the points which we really take into account for the inspection is high turbulence or high velocity zones, condensation points, dead ends and high stress points, areas immediately downstream of chemical injection points, and all support points. Here we have to focus very severely so that we are not missing any damage which is occurring there. So then high temperature, low thickness components are mostly superheater, reheater, LTHS, upper bank coils. And of course in supercritical units, even the upper furnace area also will be coming under this. So we have to see complete visual dimensional in situ axial scale thickness measurement, which will give the remaining remnant life also. Tube sampling for mechanical and metallurgical testing are to be collected. DMW joints, that is dissimilar metal weld joints, are to be replaced at least once in 1 lakh hours, irrespective of the nature, because the experience shows like that. So tube, then remnant life techniques which are adopted here for the tubes are tube hard bus test and axial scale measurement, which can be used for life assessment. So then low temperature, low thickness components, which we have already seen. So we can see low water valve panels, steam cool valve panels, what all the testing to be carried out. So here one thing is that we have to do the tube sampling for deposit analysis of water valve tubes so that we can understand whether it has been affected by hydrogen embedment for any other corrosion pitting, etc. And preferably the tube samples are to be selected above the burner zone, minimum of 1.5 meter above the burner, which will give us the significant information so that we can understand whether there is a deposit quantity. If the deposit quantity is more than 40 milligram per centimeter square, then we have to suggest for chemical cleaning of the boiler. Solvent selection can be also based on that. So when it is coming to sampling of tubes for laboratory analysis, for water valve, for metallurgical and deposit analysis, we have to take water valve samples. Preferably, the entire furnace is to be covered. That is what I was telling, above the burner zone, 1.5 meter above the burner, in all 4 valves, preferably in the mid-region, we have to take, and tube sample should be to a length of around 1.5 meters. Immediately after taking the sample, both ends are to be capped and the deposits should not be allowed to fall off. And that is to be given to the laboratory for testing. Then when it is coming to economizer and LTHS tubes, we have to collect sample for metallurgical analysis and flattened superheater, final superheater, reheater coils. Again, we have to go in for creep rupture test and axial scale thickness analysis. And if in case if axial scale thickness is found to be more, then definitely these coils in situ axial scale thickness measurement also can be planned in case if it is more. So laboratory testing, generally people go in for microscopic examination, deposit analysis, accelerator creep rupture testing, and mechanical and metallurgical tests, tensile stress, etc. So then comes, of course, metallurgical replication for high temperature headers and piping. We have to necessarily do this because this is a non-destructive method. So we can go in for mechanical polishing method and chemical polishing method. Both techniques are available, and we can do this replication, and that will take the microstructure replica, and that can be analyzed through the microscope, and we can understand what is the kind of cavity formation or whether it is free from cavities. Based on that, we can understand how to go about it. So this were how they are doing the polishing and how they are taking the replication, that is all depicted here. So you can see here the creep pores, what has already taken place. This is the gold sputtered replica microstructure wherein the creep orientation is also there. So we can go in for that Biddle-Nyberg curve. That will clearly show up to point A, there is nothing to worry about the metallurgical condition. And when it is coming to point number B, it is isolated cavities. So these isolated cavities between A to B, we have to see how to go about the periodicity of the re-inspection. And coming to oriented cavities, we have to become more worried. And here we have to stipulate the time like 1 to 1.5 years only for the retesting. We should not allow any more time. And when it is coming to micro cracks, of course, this is the stage where we have to plan for the replacement. We cannot wait up to the macro cracks to take place, and then it will be a sporadic big accident and other things will take place. So stage number D is not at all recommended. Stage number C, we have to be very careful and we have to plan for the replacement. Up to point B, we are always safe and we can go on, do the inspection, and we can give the further period of operation without much issues. Axial scale thickness analysis is another very important tool which can really predict the life of the superheater, reheater tubes and high temperature tubes. So here we can take the steam side axial scale measurement through ultrasonic testing. And with the master creep rupture data and tube dimensions, we can calculate the remaining life. There are formulas available. And the life prediction can be computed through history-based computation, sample tube analysis, creep rupture testing. Creep rupture testing is nothing but the sample tube is taken and it is subjected in the high temperature furnace with the fixed pressure in that, and at 3 different elevated temperatures the tube is allowed to fail. Then a curve is made out of it, and we can, for the operating temperature, we can always extrapolate and find out what is the remaining left out life. That way, axial scale thickness measurement also, that life prediction can be made. So in situ hydrogen damage, how they have just performing in the water wall tubes, which we have seen there, this one. And here the ligament crack detection by ultrasonic testing is shown here. And recommendation format of any typical condition assessment and RLA is remaining life and inspection intervals of the components, parts needing replacement, parts needing repair, and chemical cleaning advice and procedure, modification required for life extension, advice on water regimes, improvement in operational methods. Suppose continuous operation of high temperature or high pressure should be brought out and it should be informed to the operating team so that operational method improvements, whatever is to be done, that can be made into a format and it is to be strictly followed to avoid any further failures. Future plans of test also have to come into it. IBR, as per our 391A class, we have to do the repeat of the testing in 5 to 6 years period. And future plans of test, that is what we are discussing, retrofits and improvements, and any other specific observation also have to be brought out. This is what should be there in the RLA recommendation format. And up to this, this is a general thing. Any questions I would like to answer. And there are some case studies which are available if the participants is late hours. And if you like, I would just go through that also. And before that, if you want to ask any questions, you can do it. I will ask them to just go to the another file and just put the case studies. Some 6 case studies are there that I will rush up and show you. Yeah, please, sir.
One of the things for a life assessment is, that you have to adopt a defect-tolerant design philosophy. That is, you have to assume that everything that you produce has got a defect. If you cannot detect it, you assume that that defect is. That is what defect tolerant. We have a crack. Then, you have to monitor this, because how do you define failure? the crack grows to a critical size. That is a failure thing, you know. So you have to monitor this crack. So long it is subcritical, we can use that. So two types of failure can take place. One is a brittle failure, another is a ductile failure because you may exceed yield strength or UTS. In between that, you have a failure assessment diagram. So nowadays, my question is, in your power plants, are people adopting this philosophy where, you know, to live with the defect, monitor, you know, that how the defect is growing and when it is coming to the end life, like adopting API 579.
You are very correct, sir. Actually, that is what I was trying to tell with respect to the creep rupture test. So, for high temperature, the tubes, we are trying to do this creep rupture test and understand how much defect has already occurred and how much further operation is available, and that we will be able to do the remnant life calculation. And with respect to axial scale thickness also, we can do the same. So, how much defect is already there and how much defect we can further allow, and what are the preventions we can put in. That is what operation parameters and maintenance aspect what we have to take care. If we can bring in the longevity of the life can be definitely improved and it can go for further operation without a failure. So we can go for predictable maintenance rather than preventive maintenance also. Nowadays, this tool is a very good tool for predictive maintenance and ensuring the reliable operation.
So you are correct. Actually, these things are okay when you are on a base load. We know like what your operations will be in the coming years. But today things have changed. You know, certain plants, certain states, it can be cyclic, seasonal, or say a regular affair, but they are cycling. And even if you take a data of number of starts, number of cold, hot, warm, whatever it is, but you know, it's the way you are starting it. Like even if you operate as per the manufacturer's curve, there is some damage. And we have done some studies. We are checking just 2 operators we are comparing. One operator did 16 times more damage. So today there are tools which can tell you damages online. So no need to go into, otherwise it's not possible and people can, otherwise how many people would do like FEM analysis and all those complicated things. So today there are available, all those tools.
You are very correct. And online, today online monitoring system and softwares are available, which is being installed in the power plant, the new power plants, which are being installed along with the initial erection and commissioning time itself. And that will monitor the condition and that will tell us where is, it will provoke us actually. Tell us that this escalation has taken place, so we may have to do this. So in the next shutdown, physical inspection also can be carried out based on the data. So that is one good thing which is available today. RLA software itself is available, which can be installed, and retrofit also can be carried out. This point, why I am trying to talk about is that definitely this is one of the tools which are available today, but one thing is that the validity of the software and how much data has gone into it. Today, anyway, with AI going to come in a long way, in a big way, we are definitely sure that these softwares will go on improving by itself by artificial intelligence when we are trying to put in. And definitely, I think in the future, it will help us and guide us, apart from the physical study. It is going to be there. It is being installed in our new plants, and old plants also people should consider that.
Yeah, you are correct, sir. This thing is existing since long. If you see, it's even mentioned in ASME documents. I was just going through it, 1973. Old, and only thing, question in India, there's lack of adoption. People are not adopting it. But no, definitely, yeah, now there is a need for that.
Yeah. It is the will what we have to have. Actually speaking, when in 2002 to 2004 itself, when I was working with Mahaj & Co., I want to share that experience. So I was a committee member in the tube failure reduction task force, and we were going around all the power stations. In fact, 4 to 6 failures per annum per boiler was there at the time. Then when we have put the data properly into it, Mr. Kate was also one of the member. So we had brought down the failure to nearly 1.5 to 2 failure per year per boiler. Like that we have done. And of course, those days, the technological improvements on these online monitoring systems were less. In fact, today it is being available and we should make use of that to the maximum. But irrespective of that, the IBR 1950 regulation it should be followed so that we are not facing any problem catastrophically. So we have to take care physical inspection also. Otherwise, no, this physical inspection methodology would be forgotten and they will postpone the overhauling period. Already now it has become once in 2 years. And because of that, the issues like erosion, the monitoring will become a problem actually. Erosion monitoring and all is not really captured in the online system because it has to be physically measured and it is to be fed into the system. Many of the dimensional measurements are to be fed into the system. So we have to do the regular measurements and it has to be put into the system, online system, so that it study in a holistic manner and gives us the result.
Okay, I think we should.
One question.
Yes, yes. May I interrupt, sir? We are running short of time, so sorry, but we need to stop the Q&A session.
Can I ask one question, sir?
Okay, one quick question, please.
Sir, as you have mentioned, my name is R.J. Kamudi, competent person as per Factories Act, and you mentioned in one of the slides that 27 phenomena occurs failure of the boiler. Whether at every scheduled inspection, all the points are taken care of. Just one part is working, it is about to finish 1 lakh hours of operation. But nearby there will be something wrong in the welding. So that will be also taken care or not in the inspection.
Yeah, your point is correct, sir. That's why a dedicated approach during the condition assessment is very much required. We have to classify the total components into the 4 groups what we have discussed, and we have to go for the complete module of testing, and we do it properly and not to just satisfy the boiler board. People have to take into heart that this is to be done genuinely so that you are not missing any point. All the mechanisms can be brought out. All the problems can be brought out. But it needs a dedicated effort, and without participation of the operating plant staff, especially maintenance staff, it is not going to be successful. It is not the RLA agency alone can do it and they can bring out the results. It is the holistic approach and it has to be hand in hand together. We have to understand every aspect, and some good amount of time is to be spent on the first phase of activity. That is the data analysis of the earlier failures and earlier maintenance practices, replacements carried out, and what else we have to do like that. So with that only definitely all the points can be taken care, sir.
Thank you. Yeah. Thank you, sir.
Okay.
So the case studies, if you are interested, just I can go through. So it may show some of the interesting facts. Can you just put the case studies? Just we will go through it quickly.
Sorry, sir, but sorry. No, I don't want to close it, but we are already running late, and Nagamanikam sir is available. I think tomorrow also you will be here.
No, I'm just leaving tomorrow morning,
okay.
early morning.
Yes, sir.
Yeah, 1 or 2 points I think we can see.
Okay. Just, as the director sir says, okay.
Just show that second file, sir, please. Case studies. People are. Just, okay. So you can see here with how we could save a boiler operation with boiler board help. Actually, the secondary superheater outlet header, with the fibroscopic inspection, it was showing the ligament cracks only in the left extreme. And with a lot of discussion and boiler board's intervention, the one portion of the header was removed along with the coils, and with reduced load, the boiler was allowed to operate. And so by that, then in the next opportunity, the entire header was replaced with full coils and full load was achieved later. So this is one of the classic example, which was in Gujarat only. And the ligament cracks, what has been identified is this. And you can see here, same thing, it was in Maharashtra. This showed actually, you can see here, ligament cracks particularly near the T-piece in hot reheat header and misalignment of coils in reheater. And so you can see here, this was again very carefully we have taken a decision to continue the operation, and then when the replacement was to be made, accordingly the replacement was made, and then the plant was saved and it was operated. So here you can see the creep failure of superheated tubes, and the two, even stainless steel tubes have faced the problem. This because of excursion of temperatures during operation. They wanted to run the unit somehow and make the generation, which has made the creep to come in such a large way. And you can see that they are overloading, overfiring of the boiler beyond the rated capacity, and high startup rate also. These two things were making the problem. And this was again radial crackers in ligament area. You can see, just I will go through that. You can see how the final super inlet header has been seen with cracks. So this header has to be replaced. Oxide scale thickness in the reheater coil, this was copper gada only at that time. So the oxide scale went up to something like 1.86, almost the life was consumed. So then it was suggested to go for replacement. Hydrogen embitterment again, you can see here how the tube will open during hydrogen embitterment. So then chemical cleaning has to be carried out to make sure that the boiler is not facing the problem further. So this is the microstructure of that. Water regime of the plant is to be re-examined, and we have to see that it is maintained. So with this, I thank you very much for giving me listening.
Thank you very much, sir. Yes, please be on the stage for few minutes. Yes, and I call upon Mr. Sandeep Chivte, sir, Joint Director, Pune, to felicitate Mr. Nagamanikam, sir. Please be on the stage. So, audience, condition assessments and conditioning monitoring of boiler pressure parts and components as per IBR 391A. Just now, Nagamanikam sir has delivered his knowledgeable session on this part, and now we will have a very quick and short session just to elaborate this topic, and for this we will have Mr. Gajanan Wankhede sir on stage, Joint Director, Mumbai. Let me introduce Mr. Wankhede sir. As all of you know him still, he is basically BE Mechanical and MBA Operations. 12 years experience at Chandrapur Super Thermal Power Station, 18 years at Directorate of Steam Boilers, 2016 to 2022 Secretary in Board of Examiners, and 2021 to till date member Gasket and Packing. Okay, so please welcome on stage Mr. Gajanan Wankhede sir. He will highlight some points on amendments with regards to RLA and Regulation 371 FF of IBR 1950. Sir, are you comfortable here? Yeah.
गुड इव्हनिंग एव्हरीबडी. ॲक्च्युली आता गुड नाईट म्हणायची वेळ येऊ नये अशा वेळी मला दिलेला आहे. अँड आय एम टोल्ड दॅट यू आर हॅव्हिंग ओनली 10 minutes. But sure, I will wind up in 10 minutes. I will show only 2 slides. Many people ask, what is the life of boiler? Many manufacturers say, life of boiler is 20 years. Some say 25 years. That may be for doing their business, I think. But as a regulatory body, we say boiler amar hai. Boiler amar hai. As a regulatory body, we say boiler amar hai because we are having boiler which are in service for last 100 years. So there is not such life of boiler. Then what should be our activity? What should be our action plan to keep this boiler in safe condition? Mr. Nagamanikam already told about RLA study. He told what tests to be carried out. Now I will tell when it is to be carried out. Now RLA, there are 2 types of boiler. One is shell type, one is water tube. In shell type boilers, after every 25 years, we reduce the working pressure of boiler by 5%. There one table is there, it is already in the book. So I will not go into details because I am given only 10 minutes, right? So second part is water tube boilers. In water tube boilers, the boilers which are operating above 400 degrees centigrade, then those boilers after running of 1 lakh hours, they are to be tested by RLA as per table 1 of IBR. Then the boilers which are operating below 400 degrees centigrade and those who have completed 25 years of life, they are to be tested as per table 2 of IBR. And one wasted boilers which are operating above 400 degrees centigrade and those who have completed 1 lakh running hours, they are to be tested as per table 3 of IBR. And the other remaining boilers which are below 400 degrees centigrade and below 50 degrees centigrade, no such elaborative study, RLA study is to be carried out. Only headers and drums and headers are to be tested as per only UT, MPT and LPT. Those 3 tests are to be done. Now, second point, there's when the RLE is to be carried out, it is covered. Now, second point, many people say for what is the certification period of a boiler, whether it should be 1 year, 2 years, 3 years. Normally, for all boilers, the certification period is 1 year. But only for power boilers and wastage boilers working in continuous process plant, they can be certified for more than 1 year. So I will show 2 slides only. It is a summary of all this. This is for boilers used exclusively in electric power generation plants. When the boiler is having pressure of more than 100 kg per centigrade, operating pressure more than 100 kg per centimeter square, and the running hours are below 1 lakh running hours, then it is eligible to be certified for 24 months. But we certify it for first 12 months, and after 12 months, we check the parameters, online parameters only, and then recertify it for another 12 months. Only that means total certificate is for 24 months. Second category is boilers which are operating below 100 kg centimeter square and above 400 degree centigrade, below 100 kg per centimeter square and below 400 degree centigrade. For boilers having more than 400 degree centigrade, the hours of operation is 1 lakh hours, and for boilers which are operating below 400 degree centigrade, the life period is 25 years. Such boilers are eligible for recertification after 12 months. So here also we can certify a boiler for 12 plus 12, that is 24 months. But after 24 months, every boiler is to be offered for inspection, regular inspection. But this is one is JAC. If the pressure is more than 100 kg per centimeter square and the operation hours are more than 1 lakh hours, then these type of boilers, these boilers are to be inspected every year. But if RLA is carried out as per regulation 391A, then this type of boilers also can be certified, recertified for another 12 months. So total validity period will be 24 months. Another is JAD, where pressure is less than 100 kg per centimeter square, temperature is more than 400 degrees centigrade, and hours of operation are more than 1 lakh running hours. Pressure is 100 kg per centimeter square and temperature is below 400 degrees centigrade, and hours of operation 25 years, then such boilers are not eligible for certification after 12 months. But if the RLA is carried out, then these boilers also can be certified for further 1 year without stopping the boiler. So total validity of the boiler is 24 months. After 24 months, every power plant boiler is to be offered for inspection as per regular procedure. Right? Now, I will go to second slide. Sorry, I am running fast because only 10 minutes are given. Now, these boilers are related to the boilers, wasted boilers, working in continuous process plant. Here there are 4 types. One is fired boilers, and the age of boiler is up to 20 years. These boilers can be certified up to maximum 36 months. First, we will certify it for 12 months. After 12 months, the online inspection will be carried out. In this online inspection, we will check the superheater, reheater data, then water quality, history of shutdowns. So there is no need to stop the boiler after 12 months. So after 12 months and after 24 months, this online inspection is to be done. So these types of boiler can be certified for maximum period of 36 months. Second category is wasted boiler unfired and up to 20 years of age. These boilers are firstly certified for 24 months. Then after 24 months, online inspection, as I told earlier, will be carried out. And after online inspection, the boiler will be certified for another 24 months. So total validity of certificate for wasted boilers which are having age less than 20 years will be 48 months, means 4 years, maximum 4 years. Third one is the boilers which are fired but more than 20 years of age. Such boilers are to be inspected every year as per regular procedure. But if the RLE is carried out as per regulation 391A, then such boilers can be certified as per JBA. That means those boilers can be certified up to maximum 36 months. Fourth category is unfired boilers, which are having more than 20 years of age. These boilers are also to be inspected every year. But if the RLE is carried out as per regulation 391A, then such boilers can also be certified for maximum period of 48 months. So this is the synopsis and summary for certification of boilers in power plant and wasted boilers working in continuous process plant. Thank you. No. This is not based on data. This is as per regulations, Indian boiler regulations. There is one regulation. It is called Regulation 376 FF and Regulation 376 FFF. Regulation 376 FF is for power station boilers and Regulation 376 FFF is for wasted boilers working in continuous process plant. Yeah. Yeah. Yes. Yeah. Yeah. Sure. That's why in every inspection, detailed inspection, we carry out thorough inspection, we carry out NDT test, and if there are defects, we replace the defective part. And so that part is as good as new part. Okay.
Yes. Thank you very much, sir, for sticking to your word and completing your knowledgeable session in given time. And sorry, because as we know, we could assign a very short period for your session. And yes, for this knowledgeable session, we'll felicitate Mr. Rankine, sir, and can I have Mr. Sachin Chaudhary, sir, in charge, Joint Director, Nagpur, to do the honors? And with your huge round of applause, we'll congratulate Rankine, sir, for organizing Boiler India 2024 successfully hitting the hat trick. Thank you so much. And now, here we end today's knowledgeable sessions. I request all of you to stand up. राष्ट्रगान के सम्मान में आप सब खड़े रहेंगे. राष्ट्रगीत से हम प्रोग्राम का समापन कर रहे हैं. कल यहाँ सुबह 10:30 बजे कल के सेशंस शुरू हो जाएंगे. So please all of you stand in respect of the national anthem. राष्ट्रगीत शुरू करेंगे. शुरू कर.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता. पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा. विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा. तव शुभ नामे जागे तव शुभ आशीष मांगे. गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता. जय हे जय हे जय हे जय 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 हे.
भारत माता की वंदे. Thank you so much. And I hope to see you dot 10:30 here only. Yes. Okay, all the delegates are requested to please collect your certificates of participation. Which audit? Next.